As usual, waiting for Twitch to catch up. There we go. I should be live. Hello, everyone. Welcome back to the stream. Before I begin, a quick note. First, I have uploaded all of the backlog to YouTube. That's done. Everything in October and November so far, I was very late, but it's all uploaded to the archive YouTube channel. And the second thing I wanted to quickly address, last week, the Tuesday stream lasted for 11 hours. That was extremely fun. That was a mistake. I will not do that again for two main reasons. The first one is, like, for me, it was bad. I went to bed at like 7 a.m. That's not reasonable. But also, a big goal of this project was to try to be somewhat educational, to try to show how to do a project like this. And I really don't want to give the impression that doing 11-hour binge session is the right way to proceed. It's not. I don't have a big platform, but no matter how small it is, I think it's my responsibility to clearly say that's not the right way to do things, and I want to be very careful about the example I gave on this channel. So I will no longer be making 11-hour streams. As far as the project is concerned, we are making a lot of progress on the refactor of the analysis phase. We're getting very close to it being done, and this evening is going to be simply continuing fighting the compiler until that refactoring is done. And next week is going to be a bit different because next week I'll go back to doing the advent of code first and then resume working on this project when I'm done with the advent of code. Okay, let's go. One thing that we were blocked on at the end of last week, I had some issues. I had made a choice that I'm starting to regret, but it's not a big change, which was that in this notion of I have concrete types or partial types or parameterized types, I had said that the partial type was slightly different in the sense that it cannot be maybe at the root level. And I think that's a mistake. I think it's a bug even in some cases. So I'm going to change that, but it's going to break a few things. Namely, here in types, we have those validate functions that like try to validate a concrete type, a partial type, or a parameterized type. And here, this function now must accept a nothing at the top level because it is valid to have nothing at the top level, which means we can probably remove... No, we need the local mapping. But we can still replace this by just that. There we go. Which now we don't check that we have nothing, and we might want to add... We may want to add something that replicates the old behavior, which is a partial type. How do we call that? So a partial type that's not a placeholder at the top level. Non-empty partial type. Something like that. That's gonna be this, basically. The same thing. Except... So given a path, it's gonna be validating the partial type of that path. And on nothing... Oh, that did... Here we go. And if that gives us something that's nothing, we fail with an error. There we go. That's going to break a few things. I think the key point we need to check is where we are using validate partial type and whether we should keep validate partial type or if we should replace with validate non-empty partial type. Let's have a quick look. That's one in instantiation and the rest in expression. Okay. Here, partial type is correct. It's okay to not give just underscore a placeholder for a type in a let variable. That's perfectly fine. I think the only non-empty partial type will be for a struct expression, because while the type arguments to the struct may be empty, may be non-existent, we need to have the struct name, which means I think validate partial type. It's a function call name. For a function call, yeah, validate partial type is still correct. But here, however, is where we want to guarantee a non-empty partial type, because here we need to find a struct. We need to find a struct at least, even if the parameters are not given. And I think that's the only place where we change this. We're gonna need to change the type here, actually, because that's not gonna give us a partial type. That's not true, because partial type can be a maybe at the top level. So that's gonna be giving us something that's slightly ugly in terms of type name. It's gonna give us a type node partial functor. There we go. Okay. With that, we are probably going to be able to solve some of the remaining compilation errors that we have. I think one of those was here the error, the diagnosis is not a struct, takes a partial type. And I think most errors will need to take partial types, because we can trivially convert concrete types to partial types. That's easy. And we can trivially convert parameterized types to partial types as well. So we just need to make a concrete to partial, basically, to fix this particular error, which was in expression on line 473 here. Okay. That would probably be in types. Because I have this concretized type. Aha, and now here, that's just go. There's no need for this anymore. Reify is not what I want, because it's going from a parameterized type to something else. Can I write a generic function to partial type that would require having a notion of, for an arbitrary functor, is the value there or not? I don't think I can trivially do that. There might be a way, but none that... If I were to require it to be a monoid of some kind, possibly? But I can't guarantee that it will be the case. Okay, so let's not do that. So we have reify that makes it from a parameterized type into something else. We have concretize that from a partial type makes it concrete. How do we call the function that makes... How do we call the function that takes a concrete type or a parameterized type and makes it a partial type? I'm trying to think of, like, is there a solution to... No, I don't think there's a generic solution. I don't think I can write a generic function for this. So I might just be very explicit and partial to concrete, which is going to be a function. Well, it's going to be the other way around. Concrete to partial, which is going to take a concrete type, return a partial type. And we're gonna do parameterized to partial, which is gonna be the exact same thing. What annoys me a tiny bit is that it feels like those functions are all the exact same structure, which makes me wonder if there is a way we could write some lens, some plated thing. Actually, that's plated. Did they make an instance of plated? Let's do a slight side thing. Do I have an instance of plated for my types, actually? I don't think I have an instance of plated for it. I should. I should absolutely have an instance of plated for it. It is a self-recursive type. Let's just copy this. Just to have it in scope, I need struct type info and function type info as well. It is the most difficult part of this entire project, is working with such a high zoom level and therefore with so little context on the screen at a given type. Function type info, there we go. Okay. So what I need to write is plate that takes a function f that applies to the type here, which is going to be some type. Do I make it on type node or do I make it on type tree? I think I need to make it on type tree because that's the thing that actually shows up recursively. So this needs to be on type tree of f. And I need to be careful. That's the f at the type level. That's the f. That's the function. But otherwise, it's still, when I have an int type. Well, that's not true. This takes. That's not true. This takes an int in a type tree, not a type node. So this would be traversing. Now I can do this. If I find an int type that's just pure the int type, and likewise for all of the other basic ones. Go. For an enum, there's no need to do anything recursively either. That's just name values. We return the same thing. In fact, since we are returning this exact same type, I can instead put all of those as, in the case of a leaf, return pure of the leaf. I don't need to detail them. The only ones I need to detail are the struct type and the function type. I'm too used to the cases where we actually perform a transformation. Hello, how are you? I'm too used to the cases where we perform a transformation I have to explicitly match all the constructors and reconstruct them. In this case, I don't. So, a struct info. Here, this will be a struct type info that we can just deconstruct. And the result will be a struct type. Yep, sorry, I uploaded everything yesterday or today. I don't remember. I think this morning I uploaded everything, or was it yesterday? No, yesterday. I uploaded everything yesterday. And yeah, another thing is like last week was an 11-hour stream was absolutely unreasonable. I am not going to do that again. That was not a good idea. But yeah, I uploaded everything. I haven't clipped things from the stream last week. That's the last thing I have to do. But yes, otherwise the archive channel is up to date. And this time I haven't missed any stream because there's been one stream or two in the history of the project where I didn't upload them in time and they got deleted by Twitch. I haven't missed any this time. I was just very late. So here, what do we want to do? We have a list of type tree, which is the type on which we have the thing, which is the arguments to our function. So here, at the core of this will be a traverse 2. No, actually, just a traverse. Just a traverse of f on our struct type params, which will give us the transform version of this. And I suppose then with that result, we can just recreate. I guess I can apply the lens for this, in fact. I'm currently looking for a new job. I've been working in tech for 2 decades at this point. God, yeah, 2 decades at this point. And I've done a bunch of different tech jobs. I've been in SRE, I've been a SWE, I've been working with Haskell, I've been working with C++, I've been working with Python. Like, I've done a bunch of different things. I've even done, technically on paper, some video game development. And it's the uh, backend SWE stuff that I tend to prefer. Prod stuff is less what I care about. My ideal job, I think, would be like I've styled this as like gardener or janitor of a code base. Like, give me a large code base in a statically typed language, and I will take care of it. Yeah, no, I haven't worked on GTA 6. If I had, it would be even more delayed because, I'm not exactly the fastest. I'd like to go back to some video game development at some point, but the last time I've actually done some video game development was 15 years ago, and things have changed quite a lot since. Last time I was still at the I want to write my own game engine kind of thing, and I was still doing like manual OpenGL 4, GL begin, GL end kind of like direct mode kind of thing. So my video game knowledge is extremely rusty. If I were to go back to try to make a video game and I have a few ideas of things I'd like to make at some point, I'd probably just like use Godot or anything like or something like this, and just like do everything in Godot script and never actually touch the lower level code, because like it's interesting to know how game engines work, but if you actually want to get something done, it's not the best place to start. So here, I'm tempted to use a lens since I have lenses on those things. So I should be able to say that if I name this just info, then the result is that I apply a function on info. No, I use the how does that work again? I use the struct type params lens with the f function with traverse f, I think, even. Or is it gonna be? Or is it gonna be something like this? It might be something like this on the info, and that gives me a value the new version of the info, and I just reconstruct with struct type in the resulting monad. It's gonna be something along those lines, I think. We'll have to check. And it's gonna be somewhat similar for, and I need to wrap this, no, okay, it's perfect. I mean, look, the compiler will tell me if I'm right or wrong. And if I'm wrong, which is the most likely, we'll just see what the compiler has to say. And for a function type, the only thing we need to change is going to be now for the function type is going to be more complicated because there are going to be types within this and within this field. So here I'm probably going to be a bit more explicit. I'm not going to be doing some length shenanigans. Let's deconstruct the function type info. Let's open a do block. The new fun args are going to be the result of doing... It's not exactly going to be a traverse because I need to then deconstruct this thing. It's not going to be exactly a traverse because we are going to have to deconstruct this thing, which is annoying. So it's going to be something like a traverse 2, because we go through the list, we go through the tuple, and then we apply something on this. Of a traverse fun arg thing that doesn't exist yet with f our function here on the function arguments. The new fun return is going to be a very simple, that's a type tree, which is the thing on which we are operating. So it's purely applying f on the fun return. With that, we can create a new function type info, which is the function type info, which is going to be this one. Let's name it explicitly. Where the fields are going to be basically the same. The fun params are unchanged because they don't contain any type information that we need to traverse recursively. The fun args are the new fun args. And the return type is the new return type. And our result is therefore pure of a function type of this new function type info, which in hindsight, maybe we don't need to actually name, and I can just inline this rather than creating a name for one thing. Yeah, I think this is fine. Okay. Now, the only thing we're missing here will be to introduce this traverse fun arg with f, which is going to be a simple function that will deconstruct a function argument. And a function argument is, again, one of those things. I could make a lens for this, actually, and just operate with lenses here. But let's write it here again. So we have either by value or by reference, and we have the inner type. And what we do in both cases is just to reconstruct, and I fix the constructor afterwards, after applying f to the inner type. This one is by value. And there we go. Now we have plate on the types. Wait, I'm an idiot. It's not, but it's wrong. It's that it's useless. It's not useless. It's just, it's not useful for the actual purpose I have in mind, I think. Um, unless... No, I don't think it works that way. I think what I would like to have here, instead, rather than plated, what I would need to do is use either a library for the Barbie type kind of thing, or see if some of my own functions actually allow me to do something that I want. Copied this from another project of mine, so no licensing issues. And I think here what I actually want to do is some kind of... Yeah, what I want to do is I want to change... I just want to do a FF recur, where I want to translate what functor is applied to the underlying type. So it's still a type, but is it a type where we apply the concrete functor or the partial functor, basically? And the only thing I need to provide for this to work is a function from, and an f function is something that to the first functor, any value in the first functor gives me another value in the second functor. So in fact, we didn't need to do all this plated thing. So it was a fun exercise, but it was useless. The only thing I needed was... If we go back here somewhere, where is it? This is FF recur with a function that's gonna take from identity to maybe. That's trivial. That is, the function is run identity, give me the value, and then put it in a maybe by doing just. And this one will be FF recur. And here this is more... this one is from a parameterized type. And this one is from an either to a maybe, and there might be a function for this already. Let's look at our trusted Google. If I have an either EA, can I get a maybe A? Right to maybe, okay. Either to maybe. Those are in extra, interestingly. Huh. But I think I have extra already in my dependencies. Yep. So I can just either to maybe. That's what this is. And that should be... That should be it. Now, the question is... So maybe concrete type? Yeah, no, that's correct. Can I use the same FF recur thing? No, I don't think I can here. Because I'm not just converting from one thing to the other, I have to handle the possibility of it not working. Because basically what I'm trying to see is, can I reduce those big case thing where I'm doing the same thing over and over again? In fact, for this one, I think I can. Like, all of those, I'm just returning the same thing. I'm just returning the same thing. So I think, yeah, all of those cases I can I can remove. Ah, no, I might need to deconstruct them because I'm returning... Yeah, the functor is different. I can't just do cast them. Ah, that's annoying. Yeah, well, we do have to keep... Aha, here I have, however, a rewrite as FF Rika, and I think this one I can... Yeah, this doesn't need to be a maybe here anymore. Is this just... Yeah, remove parameters no longer needs to exist. This is just... This can go away entirely. This is now purely the parameterized to partial. It is this one. Okay. With that out of the way, I think we can go back trying to compile things and see where they break. Is that because it's an undecidable instance? No. Or is it that the plated has to be defined on the actual... Well, since we might not actually need the plated, I might just not bother with this instance for now. Because I would like it on the top level functor anyway, and that might not work very well. Okay, so let's go back. I suspect several errors are going to be the problem of like, I've changed the way the partial type can be maybe or cannot be maybe. So we're going to have to fix that. And in fact, indeed, expected path info, something that gives me a partial type, actual, something that gives me maybe a partial type. So we need to fix that because partial type contains the possibility of maybe already. Because indeed, here I didn't fix... There we go. Uh-huh. So here I have... Do I need those type annotations? What happens if I remove them? Is it going to be confused? It seems to be confused, but between maybe stuff again. So let's have a look at validate type alias type. That gives me a type tree of f, which will be a partial type or a concrete type or whatever kind of type we are actually dealing with. Okay. So in the case of a partial, that seems correct. Oh, is it the mappings that are wrong? Yes, it's the mappings that are wrong. The rest is fine. Okay. And now here is where the annotations were needed. So this is with the partial functor. I'm gonna put it back. And I think similarly for this one, we're gonna keep it. Okay. Remove parameters no longer exist. This is transforming a parameterized type into a partial type. So this is parameterized to partial. Because in error messages, I think we basically always want partial. With maybe. In the first error of error incompatible type, that means I probably have a few maybe partial type in a few places. I do indeed. I have maybe partial type, which is no longer required. Partial type contains its own maybe now. Okay. Let's see where we're going next. I have here a maybe partial type that's wrong. We fixed that here. In fact, can I have a quick look at maybe partial type? Only one in expression. And I'm just gonna make that partial type instead. Oh, module extra is deprecated. You should import the more specific modules directly. Okay. Either to maybe is provided in data either extra. Okay. And not in this file though. Okay. Here, what do we have? We have a type node of a concrete functor, which is the same thing as a concrete type. And we need a maybe type node of partial functor, which is also known as a partial type. So that is a concrete to partial. Next, what do we have? We have something similar here, I think. We're at the point where we are back to the code for validating struct expressions. And all the type inference complexity is where I think we ended up being stuck last week. So I'm not surprised to be back here. Plus, we've introduced some changes to the way partial types are represented. Yeah, that's going to be a bit peculiar. So here, we're expecting a maybe. And we have only one layer of maybe. So why are we expecting 2 layers of maybe? Probably because we have a function down there that deals with... Huh. Okay, so... I wonder if we have any validate partial type in this. Not that I can see, in fact. Because here we do a validate non-empty partial type. And so here, the param types, we're zipping the struct parameters with the struct type params, okay. And indeed, those are maybe partial types, that makes sense. Wait, why are those partial types? Shouldn't they be parameterized types? Because those are the struct type params that are coming from that depends on the parameter f of the struct type info that we got here. After doing a validate struct type, this dollar is unnecessary. Oh, there's another thing I wanted to change, but I might do that when this compiles. I want to use finally in places where I like use some recursive stack thing rather than just using a try. So let's see, validate struct type. Is it a thing where I think this is a type inference here that's wrong. So validate non-empty partial type gives me not a partial type, but the concrete part of the partial type, so I can do this. But as a result, I think this was wrong because error not a struct. Error not a struct takes a partial type, which this is not. So this needs to be just other type. There we go. Huh. It's still unhappy about... So I've changed the inference there by fixing what other type is. It's still unhappy. I might need to go over this function again. And I add the types to some of the underlying things, I think. Let's see what the other errors within it are. So here, likewise, it expected a partial type and got an actual maybe. So validate type pattern. Takes a partial type indeed as an argument. So here, this should be a partial type in the call to validate param. That is then given as the first argument here. So validate param must be called with this thing being a partial type, as indicated by its name. And we are calling that on param types, which is this zip here. So those must be partial types. And those are coming from, okay, so they're just a struct type info. Obtained from this, validate non-empty partial type. So that means it is this kind of struct type info, so it should be... How on earth does this end up being wrong? Is there something wrong with my validate non-empty, actually? Maybe there is. No, that looks okay. Okay, let's look at the other errors then. Aha, indeed. That's expect const int here, which is not an error in the same function, so we're out of that function already. What do we get here? this join is incorrect, it seems, because we're expecting something. Okay, that gives a const expression. So what do? We do an expect const int. Expect const int that gives us, that's from expect, as the name suggests. That gives us a int within our validating monad. We lift a2 of f into the monad, which means we get, aha, indeed. Okay, since this is ugly as hell, I am not gonna write it this way. I'm gonna instead do a do block and do this and write it explicitly. And the result is pure of a typed int type. Actually, it's not that. It is that f map into f of the two values. Okay, I'm gonna copy this for the next place where I have to try to do some join thing that's not gonna work. This one. Yeah, this is late. Okay, I see why I've done this in this case. This might actually be okay. Okay, so we still have the struct expression code that's broken. That's fine. No, it's fine. It's not, but it's known. Yes, this gives me an int, so this needs to be something that creates int const expression. Int literal const expression. There we go. Here, I just need to replace int by boolean. Oh, except here that's not within the monad. So here it is indeed pure. And I don't have to worry about nesting things. Okay. So now we have the two errors within expected maybe got just a maybe. Expected just a maybe got maybe. So something somewhere, either there's the wrong annotation or there's just something slightly wrong. It should not be too complicated to fix once I actually take the time. And here, those are more basic errors. Those are not E1, E2 in this context. They are, I think L value and R value are what I want. What next? Type of is, that is indeed not something that exists. I meant to type info, I believe. Now, what do we have? Those two errors again. And we move to, the default case needs to be not just a boolean, but a const expression. And I'm going to replace this, name this default value, in fact, and this would be a boolean a literal const expression of the default value. And I probably want to put some new lines there for readability. This is creating a typed expression with a Boolean type of doing from maybe and the default case of doing a go recursively on the two typed values. Okay. Next, I might at this point try to address those struct things here that annoy me. This is probably like just one type annotation somewhere that's wrong, which is a tiny bit annoying. Or just like something like an fmap2 instead of an fmap, where we're expecting the wrong thing. So here, param types is where I have a problem. So validate param expects. Where else is it used? It's not used anywhere else. That's interesting. So if I type this explicitly, validate param is expecting a base name. It is expecting a type map, which, where is that? It should be a hash map from identifier to something else. In this context, it is the fields map that we have created there. And it's going to be a list of concrete type, I think. Then it's going to take a tuple, which has a parameter name, which is... Oh, the type map, no, the type map might be different. It might be... No, that's what it is. I look at type map for a list of values, and they must be concrete. So no, that's what it is. And here I have the parameter name, which is the identifier, and I have the partial type. And what I return is a validate t of m of, and what do I return? I return a concrete type. I just need to change my function to here, say for all m. There we go. Now, where do you complain with that done? Well, now I need to be more explicit. This is for any E and any M. Aha, yes. I think that's not required. I think I want to change that, but I'm going to change it when it compiles. Those hash maps actually carry a base name with them. That's ugly. I probably want to change that. Okay, what do we get here? Aha, this is where the error is from. This is where I'm doing a concretize type. Aha. So what is concretize type again? It takes a partial type and gives me a maybe concrete type, and of course I was using a bind since I thought I had a maybe before, but now this is already taking the maybe as an argument, so this bind is no longer required. This is just that. This is where the error was coming from. Okay. Oh, no, okay, this is still absolutely within... Actually, just do this for readability. This all has to be within the monad, so I cannot just do a pure here. So this gives me a Boolean value within... This gives me a Boolean value within the monad, or a maybe Boolean value, as it may be. Which means this, and then I just apply all of this within. Or I guess I could do that. Here could I could actually rewrite this as an on nothing m. That's the result. On nothing, what do? I do simply a pure of this, I suppose. Well, no, because this function gives me a Boolean. So this is pure default value. And then here I can do this, and it's typed Boolean type of a Boolean literal const expression of the result, which I can then inline back. Okay, let's go. Isn't that the whole point of the on nothing? Is that it gives me... So this is claiming that Go gives me... Ah, yeah, I suppose this and always gives me a value, I suppose. Which I think is not correct. The whole point of a maybe... Okay, the logic here is basically that I need to compare fields of a struct pairwise, and depending on the actual operator, I can decide whether the comparison is true or not, only if like all the fields give me something. So let's look at how this was handled pre-refactor. This was in core, I think. This was as part of the comparison expression within a constant. There we go. So here this was this. We return a maybe value in all of those cases. Okay. Here for each field we go recursively with the same thing. But here we do an a sum of the comparisons, which I think is what I want. Which means here, I think that's the error. And indeed, I think we have moved to a different place. This gives me an int, therefore this is an int literal const expression of the value. There we go. Indeed, here I return a integer, and here I return an addition expression. So here I suppose this is a validated int literal expression. Okay, here the data constructor struct const expression should have 2 arguments, but has been given 1. I think that's because it takes the info as well. If we look at the const expression, which is part of validated, it does indeed store the struct info. So that means I'm just gonna do it this way. The info is propagated the same because it is the same type under the hood. And is that the end? Not quite. From const expression. Huh. Oh, this is probably just an F map too then. There we go. We're back to unused imports, which is always a good sign. That means we are at the points where we have some warnings. This is a shadow. It's also shadow something. Okay. Let's say base name. Should be good enough. What else? Defined but not used. Yeah, that's fine. Probably shadows something. Let's just use base name instead. My hair is a mess this evening. Unused. Unused. Redundant constraint? I suppose, yeah, redundant constraints since this function is not implemented. There's absolutely no requirement that this be a monad diagnosis. So that's indeed technically not required. Yeah. That base name is unused because we don't have any support for built-in functions just yet. Pattern match is redundant. Yeah, that's true. I have character type twice. Did I mean to do something else here? No, I think character type can only be cast to int or to character, so that makes sense. We're just fixing warnings, which is good to do, and a sign that we're really close to the end of this file compiling. unused, so I'm just gonna defined but not used. Validate number of arguments. Is that because instead I've been using validate parameter counts with? Perfect. That means this one here is redundant. Wait. Okay, with a function name that's correct, the number of arguments doesn't need to be the same. However, for a call expression, it's a let expression. I don't need to check that, I suppose. Variables. No, I probably need to check that. Oh, I already know it here. Perfect. To do. This shadows something else. Okay. Let's call this the validated type params instead. Okay. Where are we now? Cons for a constructor is a name that makes sense. I am tempted to just hide it from lens here. Parse error because it's missing a do block. It's one at diagnosis. Not in scope with location. We are just missing location in this file. Is it data set ordered? AST no longer exists. And I think common is no longer required. That's the big change we made last time. We made it so that every module resolved validated exports what it needs explicitly, which means I should not need to import common anymore. My diagnosis comes from internal. There we go. Location comes from location. I thought I had already fixed that. Huh. What do you mean? That data set ordered doesn't export to list. I thought that was the whole point. That I could get a list back. Aha. Use toList. Ah, but this is not the toList that comes from that module. It's the one that comes from data foldable. Okay. It's just a normal one then. Okay. Okay, so here in this case, this could be either the resolved or validated. And I am looking at the definition, so those are the resolved. but the result will be validated. That's the whole point of the validation phase. This is resolved in the argument. And this is validated in the output. We're going to have this in a bunch of places, resolved in the argument, validated in the output, resolved in the input, validated in the output. Let's have a look. Output, validated. I think those input date from when I used input and output as aliases for those things, which I don't anymore. This is a validated struct info. This is a resolved, which is the input of this phase. Okay. That's an output that's validated. At least this part isn't complicated, it's just tedious. I really want at some point to just make this by reference, by value thing a functor over some kind of value within. Because all of the time I'm just deconstructing, reconstructing them. This is very annoying. Yeah, okay, when this compiles two things, I make those a some kind of functor in common, and I fix the use of I make use of finally for my stacks. Because this is annoying. So that's a validated one, and that's a resolved one. That's a the other way around. Resolved here, resolved here, validated here, validated here. This is annoying. I should just make it a functor. This is an input that's resolved. Expecting two more arguments. Const info resolved. Oh, this is a resolved const info. There we go. And here this is a resolved struct info. This is a resolved type alias info. I have removed the arguments in favor of those type aliases in the modules. Wait, no. That doesn't seem correct. It's resolved. Oh, it's just that for those I don't have... I don't have an alias for those, okay. So this means this is a type alias info, and that's a common type alias info resolved. So I suppose the same thing applies here. I'm gonna have to make a const info based on the common one. Instantiate all symbols. Okay. Instantiate all symbols. Why is that not? Is it just that I have not imported validation instantiation in the scope? It might just be that. Okay. This is dataset ordered. Now we have to do instantiation. Let's see. And sequence. Except without typo. And that's the one. There we go. AST no longer exists. Common doesn't need to be imported. I need to do something with my hair. Diagnosis is missing. It's coming from internal diagnosis. L would be for list. Except data list doesn't have cat maybes. Interesting. Is it in the prelude? Or at least my prelude? It seems to be. Perfect. Aha. That's because this is a resolved function type. Common is not in scope. Location is missing. So that's the resolved one. Do I have any input or output left in this file from before? I don't. Okay. So nothing to fix here. Okay, that's an input, so that's the resolved. That's the output, so that's the validated. And I don't need which means I can replace statement resolved by resolved statement. And I can do the same thing for validated. Common doesn't exist, but that's going to be resolved. Resolved. Actually, this one might not. No, this is probably a validated, actually. The compiler will tell me if I get it wrong anyway. This is the result, therefore this must be a validated. Resolved in input. Oh. I probably don't need control on RWS strict. I'm no longer using any RWS, I think. This is resolved in input. Oh, what does that make that a... Ah, yeah, make it a statement in the output. Interesting. So this thing returns a statement. Okay, so I'm just giving the info and returning the whole statement. That's a choice. Like, I think it would be better from like a code organization perspective to have, if this takes a resolved expression, returns a validated expression, and let the caller wrap the thing back. And I think I'm gonna do that. So this is a return statement. Which might be ambiguous in the context. We'll have to see. That's an expression statement. That's the let statement. Ah, no, in this case it's not ambiguous because I'm using the same structure across the two of them. That's an if statement. No, in the case of if, it's fine. But while statement there. And for statement there. Which means this gives me an expression. There we go. No, in fact, even for the if, I don't need to, I can just do that. And that gives me a validated if info. And I can wrap that back into an if statement. That's again a validated while info. Here, this is likewise going to be a resolved for info, validated for info, and remove the for statement here. Okay, let's see. That is indeed a resolved one. That is a validated one. That's the downside of using the same type names for the input and the output. We have to very explicitly qualify. That's my diagnosis, not my diagnostic. Wait, it is, right? Wait, which one is it? Yes, my diagnosis. Okay. Ooh, hello everyone. Iterate until M, not in scope. Let's fix that. Control monad loops, I'm missing in scope. Okay, I'm at the end. So you're arriving at the end of a month-long refactor. Well, and hopefully. if everything goes well. It's been a month-long refactor, and I am at the point where most of the work is done, and it's just about making it compile at this point. So I'm slowly going through all of the errors accumulated from a month of changing everything and trying to make sure this compiles. But yeah, it's the seems to be getting close to a point where we can go back to actually the interesting part of the compiler. It is a fun project. I've been working on it on and off since March this year. I was hoping to have it done before the advent of code, so I could generate some actual Pete solutions for the advent of code. The advent of code starts on Monday, so I will not be able to do that. So starting on Monday, I'll alternate. I'll go back to streaming the advent of code a bit in Haskell, and then go back to working on the project. Or maybe perhaps if it's late at night, I'm tired, do a tiny bit of the advent of code in Brainfuck because that's fun. Yeah, there's a bunch of other languages I want to try for this advent of code, but not on stream because I don't know them well enough to feel like I have like things to, you know, show to the world on stream. I think this year I've started having a look at what I wanted to do. I think I'm gonna try TypeScript. I might try Lean. I kind of want to try Unison as well. Unison is interesting, and they've just reached 1.0, so that might be the ones I'm gonna try. Oh yeah, the goal originally was to have this done to be able to use it for AOC, but it will not be there because again, unless magically we finish the project this evening, but I'm not trying to do that. Where are we trying to make this compile? What do we get here? Oh yes, indeed, I do a uses that takes a lens into our state, but expect a function afterwards. Since I'm not trying to apply a function, I think what I want is just a regular use instead. What do we have here then? Process batch seems to be expecting a sequence, and I'm giving it a list. That's probably coming. So let's check our validation monad. Our validation monad, the state that we are carrying around, what do we have? We have this instance request that is indeed a sequence. Because the way we do things, we process the entire module, so we process all of the definitions, so we have all the types, and we don't do function analysis, well, validation immediately. Because that way, if we have processed all the types, including all the function types, it means we can do mutually recursive functions without having to a problem of like order of declaration. So every time we encounter a function that needs to be instantiated, we put it in the queue of things to instantiate. That queue might still grow because if a function calls a generic function, a concrete function calls a generic function, then that generic function must be instantiated, it's pushed back in the queue, and so on. So we have this function here that does a iterate until m, and the condition for the until is the sequence is null, and the function we do at every iteration is process a batch. And what we do when we do that is we reset the queue of instances in the state to empty. We process all of them one by one, and then we return the new, and this is going to be the same thing. This is a use here. We return the new sequence, and we continue to iterate until processing some of the functions did not yield more function to process. Okay. So, the issue here seems to be that something in process batch, because I haven't given an explicit type here, so the type is like assumed by the compiler, believes that this thing of requests is a list, while in fact it is not. And indeed, I do a traverse here, and then I do a from list on the result, which indeed will not work. Is there a way to create a hash map not from a list, but from an other foldable thing? I mean, there is probably, but is there a function for this? And the answer seems to be no. However, I think unions, because I'm doing a regular from list. Let's see, does unions? No, it also takes a list. Okay. So I guess I could try to rewrite this as a fold on whatever the container is, but maybe the simplest thing to do here is just to say, well, actually, no, this is a sequence, like sequence to list. And that's fine. I'm hoping that list fusion here anyway will avoid that being too horrible. Sequence does export to list, so I just have to use the regular one, I suppose. Okay. Base name, not in scope. What is this? So with context is something that also comes from our monad here. Since we do analysis of things potentially recursively, because a constant A can depend on a constant B that depends on a constant C and so on, like definitions might require like ensuring that another definition has been processed. We stack a new context on top every time using this with context thing, for which actually I'm going to put a to do here. I want to switch this to using finally rather than doing a try and then an ensure. Excuse me. So this requires the base names that the context in which we are processing knows what the name of the thing we are validating is, so that error reporting can get the name out of the context, which means here this with context that calls instantiate afterwards must know the base name, and we have it here. That's this thing here. Okay. Next, what do we have? Definition is not something that's in scope, so I probably have copied this line of code from somewhere else and it's just wrong. Do I have something that says located in scope? I do. Wait, I'm giving the entire function instantiation request as an argument to this. Function instantiation request is also a type defined here in this file that has our monad and our context. And that's okay, so the definition is right there. So this will be extracting the location from the definition. So here, I probably don't need to name it. But I might want to name it just that it's a bit more readable, unless I do indent things this way. And this is indeed the location of the definition. And this thing here does, we try to see, okay, we need this symbol as part of this compilation unit. Like this particular compilation unit we were actually compiling does call a generic function foo from another module with type argument int. Therefore, foo of int must be included in the symbols of this compilation unit. We first check that we haven't already processed it, that it's not already in our cache. If it's not, we try looking it up in the cache we have from other compilation units, because if we've already tried to compile foo of int as part of this process, we might just reuse the symbol. And otherwise, if we don't, then we call instantiate here, which does the validation for an actual function. Oops, and I meant to remove an empty line here. That's not required. So, what do we have here? So this returns a tuple name maybe, and it seems that the way I use it afterwards is not consistent with that type, okay? Indeed, here I'm doing a cat maybes to keep only the ones for which we succeeded, because the compilation will fail anyway if any of them failed, so it's fine to do that and just do a cat maybe and only create the hash map with the ones that succeeded. Because I do a try for each of them. Could I do something else? Instead of doing this and the cat maybe, would it make more sense? Would it make more sense to try all of them, then do a sequence basically to obtain a container if all of them succeeded, and otherwise throw the error back up, basically? No, I guess the upside of this method, where I just do a cat maybe, I ignore all the ones that failed, is that I will try to compile as many functions as possible. So if I have two functions in my compilation unit, one like foo and bar, and foo actually instantiates some generic functions, but bar fails to compile, since I'm just gonna ignore it for now, since the compilation as a whole will fail, I will still try to compile the functions that foo instantiated, which means that I will give more error messages to the user if something went wrong. So yeah, we try. That means we're gonna try to compile more things than if we were to like just, okay, look at a batch and stop if something went wrong. So I think this approach is better. However, that means I need to ignore the maybes from the result. So cat maybes on the list that contains a bunch of maybe values to obtain the actual list of values that succeeded, to then create a hash map. So that it means the result of this must be within my monad a list of maybe tuple key value. And here instead I have a list of tuple key maybe value. So what I need to do is to fmap the key within the maybe value to obtain a maybe key value. Could I rewrite this as a sequence? I think I can. If I do a sequence A of 3 and just true, I do get just 3 and true. Yeah, a sequence will work rather than fmap there, I suppose. Okay. Next. Couldn't expect. Okay, so expected argument here would be a function that, given the sequence and a hash map, the hash map here is expected to be of maybe values? Interesting. So here, that means somewhere here, I use the cache value as a maybe value, but that's wrong. Okay. Wait, is that correct? Yes, it is. It is indeed. Okay. So I create the name. If it's already in the cache, then, which is this thing, then this function doesn't have to return anything. Pure nothing is, I think, correct. However, the problem is that this function, the cache, here's something in the type inference makes it believe that this cache should contain maybe function info, and in fact it does not. Aha. Here I do a union of the cache and the new symbols, which is then used as the next argument afterwards. So it means whatever the type here, it must be compatible with the type here. That is fine. In fact, for the sake of being explicit, let's type this function. Process batch takes, again, we have said this is a sequence. Where are you? This is a sequence of function instantiation request. And it takes a hash map, or cache, that's a tuple actually, and a hash map from a name, which is the unique name of a symbol that uniquely identifies it within a binary, to the result, which is going to be a validated function info. There we go. And the result of this is a value in our validation monad. And said value is the new thing, so the new tuple. So it's basically the same thing here as this. Which is why the union here should be fine. So I suppose that means something here does a check in the cache. We don't use the cache. That's the thing that surprises me. Unless something is wrong with this. Okay, let's see. Because at first we just call empty on the cache, so there's no value that we give here. And I will need to change one thing. I need to make this a for all m, so that the compiler knows that the m here is the same as the one here in the declaration of my function. Okay. And we do indeed have a problem of validated function info versus maybe validated function info. So the actual is take a function. Oh, is it because a symbol cache is actually a different type? No, surely that can't be right. Oh, I think I know what I think I know what the problem is. Because a symbol cache is, yeah, a hash map name to validated function info, indeed. And I know what the problem is. The problem is here I do a cat maybes as if this thing were to give me maybe values. It does not. I just need a second here. And there we go. Now this compiles. I can remove this slightly too verbose thing that's not required. Okay. So what do we have here? So this is a function instantiation request, as we have, and the type is, oh yeah, that's completely wrong. That is indeed a function type info. That is something that's completely different. That is not a resolved function type. That is a validated, that's a function type info. Will that be a problem? Let's see. Current name is applied to too few arguments. Current name. Ah, indeed, current name is just the lens. So I need to do a use current name rather than just calling it directly. Okay. Here, validate the block. Validate block expects a initialization function, which here is not required, so that's just pass. Here again, I will want to replace this by a use of finally. What do we have next? What is the difference? This expected a validated block, and it found a list of statements. I thought those two things were the same thing. Aha, no. A block, the common block contains location information that I do not require anymore. Okay. Ah, but that's annoying because I am reusing a bunch of things. I'm using the common if and the common else and all of those have. Okay, so that means I'm gonna need to extend my trees that grow even more. So I go back to common. I suppose, because yeah, for the output, no, actually, I need the location in the output as well. I need the location in the output as well, because during the lowering into IR, which is the next phase after the analysis, there are still some errors that can be thrown, some things that can make the compilation fail. And when that happens, I will still need the line location for the error reporting. Specifically, as part of the lowering into IR is when we do the control flow analysis. So things such as where is this break statement going are checked as part of the control flow analysis. And something like a break when we were not in a loop or a continue when we're not in the loop, I don't do that detection as part of the analysis anymore because it will be naturally done as part of the control flow analysis. So that means when I do the control flow analysis, I might throw errors, meaning I need to have the location in scope, meaning, yeah, the block of a validate thing is indeed a common block. That points to validated statements. So, but indeed, then I see the error. That means here that this validated block here discards the location information, and that's incorrect. It needs to keep the location information. Okay. And that just means, I suppose, yeah, that we just kick the problem down the line validate statement itself takes a with location statement, must return a with location statement. And it takes I take the location because I want to set the location in my context that if an error happens there, we can just look at the current location. Okay. And I suppose then the easiest thing to do is to get the result statement, which is the result of this sub-expression. And then the result I never remember in which direction those operators go, but I have the location, which is a functor, so okay, it points to the value, which means this is result statement put in the functor of the previous statement, which is the one with location. Okay, what next? Try nested validate statement. Validate statement, not validated. Indeed, this must give me a maybe. Validate the expression here. Yeah, that looks correct. So what we do here again is we have a return statement that contains maybe an expression. If it does, we validate the expression. Then we check the type of it, and if there was no return, no expression, the type is inferred to be made to be unit. Hello, how are you? Then we look for the context for like, hey, this function we're in, what is its return type? And we check that indeed we expect this expression return type to match the expected type that we have declared as being the type of the function. And if that succeeds, we return this maybe expression that we have analyzed. Okay. What next? Here I do. You're losing to a cat. I mean, it's a worthy battle. The positive aspect is if you lose to the cat, you get cat. That's pretty nice. Less productive, but pretty nice. So here I have this try nested that composes the monad in which we do return as a result with the maybe within. So that instead of having to do a bunch of sequences when I do a traverse nested, brings the maybe back to the top. But that means here I need to use the corresponding ensure nested, basically, to decompose the functors and get my ensure out. Well, if you have a spare cat, then you will need 2 spare keyboards. Or you need a space heater that's warmer than a keyboard. Okay, so what's wrong here? No, I'm traversing the list, and this is a with location. I'm applying with location. That seems to be correct. And I try nested the result. Oh, but this gives me something that is not. That is the problem. That is the problem, which is that this gives me something that is in the composition, which is not what I want. Which means here I have to do instead the get compose to then just enter here. Maybe this is the right time to instead introduce finally. I had a quick look about this outstream, and I think the one I want is the one in exceptions, basically. The one of control monad catch. I think all of the monads I have here all have monad mask. There is no reason for any of them to not have that. Because I'm using maybe T, reader, state. Yeah, I think all of them do have monad mask. And this will provide me with a finally, which is going to be very convenient. And also with bracket, which I have use of in some places. So, rather than using a to-do for this, let's make a dependencies on exceptions. Here, import, it is just control monad catch, okay. Let's go here. So here, what do? I do a init context, and which is okay, so I do this thing always, which gives me a value. So it's basically just a bracket. I have something in my monad that gives me some kind of a value. Then I have the main body that ignores the value. That's the release, and then the actual body of the loop. Okay. So that's going to be a bracket where I'm going to have init block variables, which is going to be the entry point of our bracket. We're going to have restore variables as the finally, basically. If an error is thrown during the use, the release still happens before the error is rethrown, which is what we want. And the actual body of this will be the process block, I suppose, if I were to like name every step explicitly. And init block variables is I get the variables before they are changed, and I then run my init context thing here. That is the action that's given as an argument, because for some blocks I need to add new variables in scope. A for loop, for instance, will add a new variable to the scope of the block, and I will return those variables. But variables before, that's the ones I want to restore. Restoring variables is what I do here. I used to do here at the end, which is just to set current variables in my state back to what we had before. I could rewrite this point free, but I think I don't want to. And finally, process block ignores the variables. I don't care about them. I could almost... Yeah, I can replace this as just being get the current variables, and I can put the init context as part of the process block here, init context. And then that's just this ensure nested, which I might think that decomposes my compose of the monad and the maybe within of the try nested of the thing. Okay. That's pretty straightforward. And that avoids having to do a bunch of like, oh, we have to recompile everything. Okay, well, let's go. There's so many small things I'd like to clean about this project when I'm done with this big refactor. Okay, we still have a few errors. That's fine. Of course, now that I have imported control monad catch, the try that I have as part of my diagnosis monad is conflicting. That's fine. I only need a bracket, I think, for now, and maybe finally at some point, but for now, bracket is the only thing I need. Okay, and now, what is this? Oh, this is the thing where... Mm-hmm. You expect a maybe validated expression to a validated statement, and you get instead a maybe expression type validated. Isn't that the same thing? Isn't that the same thing? Oh, no, it's not. It is not the same thing. Um, because the expression type within the thing is actually typed expression. So that means that here this thing gives me maybe a typed expression. And I probably need to do the same thing here. Expression statement also gives me a typed validated expression. Okay. Ah. What are you unhappy about now? Validate return statement gives me a maybe valid expression. I can apply a return statement constructor on that. That should be fine. Oh, of course. This is one yet again a case of the different faces of the AST. They're all annotated differently. This is not an expression. This is an expression with location, which is perfectly fine because what validate function expression expects is actually that. Okay. I suppose it's going to be the same thing here, where this is going to be a with location here. Okay, let statement, we're going to have some similar issues. Here, this returns a let info. I have changed the way those functions are. If info here, that's correct. While info here, that's correct. Condition, yeah, that is a typed validated expression again. For info here. Okay. Let's see. Expect type not in scope. That's not a problem. That just means we need to import the proper. Let's expect there. Exp value is not something that exists anymore. That's, I think this is the typed value. There we go. This is because I have copied the code pre-refactor and it expects a different shape of types. That's why this code is basically just, we have an expression at the top level of like a statement of a function in a Rust-like language is just an expression, not an if, not a let, not like, that's just an expression. Is it an expression of, if it's an expression of type unit, that's fine. It's fine to have something that returns unit at the top level of a function, like an assignment, for instance, or a call to a function. But if it's not unit, it's probably that's weird. Something weird is going on, unless it's a function call. If it's a function call, like, sure, you're ignoring a function return value. We could do a thing. Rust has this thing of like must use, where you can decorate a function to indicate that if the result of it is not used, that's an error, or a warning at the very least. Here, it's basically I have must use as off by default for every function. If you have a function call at top level of a function, it's fine not to use the result. Otherwise, emit a warning, which means if we have like a 3 plus 4 at the top level of a function, we emit a warning. We have a top level expression that's unused. Okay. What next? Huh, interesting. Why are you? How are you still something that contains location information? I thought validate function expression would remove the location information. Let's have a look. Validate function expression gives me, given a with location resolved expression, where we have done all the name resolving but none of the type checking and validation yet, gives me a validated expression with a type annotation but without the location anymore. So validate function expression of this with location thing gives me validated expression, which is a typed validated expression. Okay. Oh, that's the wrong one here to start with. And that's the wrong one here as well. That might be why. Indeed, call expression is not a constructor that exists anymore, because now that we have a proper validation phase, we have a different expression type for the output. So it has to, the two cases where it's fine to have an expression at the top level that returns something that is not of type unit. Oh, okay, two things. First, what kind of expressions do we allow at the type level of a function without a warning? That would be calling a function by name, calling a function by dereferencing a function pointer. Those two are fine. And I think they are the only ones. Everything else should be an error or should be something of type unit. So it is function call expression, function name expression. And those take 1, 2, 3 arguments each. Wait, no, the function. Wait, where are the arguments? There we go. Why are the arguments missing? Okay, so no, this is taking 3 arguments each. Okay. Then I need, okay, I've used type matches. Perfect. Type matches is not just equality comparison on types, it is checking are those like actually compatible in this context, because there are places where we might end up with 2 different types that are compatible in a given context. For instance, there is a special void type for panex, which is the same thing that Rust uses, and a thing that gives panic is a valid argument for an int or a character. It is a valid argument for whatever. So, uh, if the type of the expression is a void because the thing panics, it will be compatible, it will be valid for the unit type here. So we're using type matches and not just equality. That means if I have something that does a panic at the top level of the function, it will never trigger a warning of you're not using the result, which I think makes sense. Okay. I've added one more argument to function call expression that's going to break something else. There we go. Which is this validate function path here. Because at the end, I have found a path to a function. So from the name, I need to, okay. Validated arguments, there we go. So here I am missing the validated arguments that I was already giving when validating not a function path. Wait. Yeah, okay. Wait, does that make sense? Oh, this is different. I am thinking of the wrong. So yeah, thank you for tuning in. I thought I was I'm in a different function than the one in which I thought I was, which is why I'm so confused. This is not I have a function call and therefore I need to figure out. I need to figure out how the function is called. This is I have a name that appears in an expression. What does it point to? If it points to the function, then initialize a function pointer. So does that mean? Yeah, a function name expression is not something that requires the arguments. Not in this way. So what did I change? I change. Ah, yes, I've added the arguments to function name expression, which is not correct. Yes, what I meant to do is function call expression or variable call expression. There we go. That was my mistake. So it's function call expression, variable call expression. There we go. That should be correct now. And validate function path. I broke something by changing stuff here. What have I broken? Oh, did I just forgot to... They just forget to save here. There we go. That's what it is. Okay. Warning, unexpected top-level expression. This is... So this is a remnant of the fact that I have changed all of the code again. I think this error, this warning, unexpected top-level expression, will never be called with a only resolved expression. I think it needs to be a validated one. There we go. Validate partial type. That's a function that exists. Let's just bring it in scope. But before I go further, let's check that this is the correct one, because I have introduced a validate non-empty partial type. But this is for let statement. Okay, that's fine. So the difference is this. When I have a let statement, like I have a let x equals 0 something, I can optionally give a type to a variable. Again, same syntax as Rust. That's the whole point. So I can say like, hey, this thing must be an int, for instance, which is one of my basic types. But I support placeholders in those things. Like I can say, when I have vectors, I don't have them yet, I will be able to say something like this. This must be a vector of things, whatever that thing ends up being. So when I do that, then I compare the type that is here with the type that is here to make sure that it shares the same shape. I call those partial types, where something that would be like this would be compatible to a concrete type. But here, that's a partial type. But I make a distinction between partial type where it can be, the whole thing can be underscore, can be a placeholder, or the top level cannot be a placeholder. In this case, it is fine. So partial type is normal. It's perfectly, it's all good. The one context in which I cannot have this is for struct expression. If I'm doing s equals pair, and I am saying x is 0 and y is 0, something like this. And if I have like a pair of underscore, that's perfectly fine. This will be inferred as int based on the context of the fact that the two fields are of type int. However, here, the top level cannot be underscore, because if it is, then we would need to do like some structural matching of like, I have two fields of type int, what struct in scope is compatible with this? And we don't want to do that. So that's the difference. In the case of a let variable, the partial type can be empty at the top level. In the case of a struct expression, it cannot. So here, validate partial type should be correct. My hair is extremely annoying this evening. Validated expression is not in scope. Okay. Okay, so what's happening here? Here I'm using the thing where I try to collect as many errors as possible before failing. So I have a let statement. I try to validate the expression of the thing. And then I try to validate the type. And then if any of those fail, I will just like throw errors back up. But at least I will have tried to collect errors on both sides before like going back up. However, here, that's annoying. Here it's going to be very annoying to do that, so I'm not going to attempt to do it for now. Let's just set the validated expression right there, which means if there is an error in the expression, I'm not going to check that the type is correct. Which means if I do something like this, let x is... What would be an example? Let's say I have a constant, let me open a thing of code. Let's say I have a constant a, which is an int, equals 0 in my scope, and I have a function foo, in which I do let x be of type A and be 3 plus true or something. A is not a type, it points to a constant. So if when I'm gonna try to, like, the first name resolving phase is gonna be like, what is A in this scope? And will point to, oh, it is this constant right there. But here in this validation phase, I will try to validate the expression, be like, oh, this expression is nonsensical, and throw an error for this statement, but I will not collect the errors on both sides before throwing the error. What I was trying to attempting to do was to do. Actually, I can probably do it. It's doable. Is to basically using the try approach thing, try to validate this, throw an error if it's wrong, try to validate this, throw an error if it's wrong, and then before trying to check that they are compatible, if any of them failed, then short circuit, because I can't check that they are consistent if any of them failed. But that way, if I do this, then the user will both get the error A, expecting a type from a constant, and try to do a plus on an int and a boolean. So let's do that. So let's try this. I'm going to say that's attempted expression. That's a name I've used in a few places. Is going to be try of validate the functional expression. The attempted type will be try of traverse of validate partial type of the resolved type, which is just a let type. And why a traverse? It's because it's a maybe. The type is optional in a let binding. Now, I've done both of those, which means now I can get the actual, so validated expression will be ensure of the attempted expression, and validated type will be ensure of the attempted type. Again, if any of those failed, this is at this point that we will just like short circuit because we cannot continue. Ensure takes a maybe value and gives me an actual value if we succeed, otherwise we short circuit. But since here we've done try on both, we will have collected errors on both before trying anything. And now that I have done both, I can do for validated type, and I get an actual type. So I'm going to only do this if there is actually something in the maybe. And the thing I can do if there's actually a type in the maybe after validation is checking validate type pattern. The validated partial type is the this one, validated partial type. Let's name it explicitly. It's this thing here, it's the pattern. And I am checking that the pattern that was given matches the shape of the type of the expression. There we go. Then I can modify my context to add into my variables the fact that there's one with that name and with that type. Okay. What next? Because we're still trying to make this thing compile after a month plus of refactoring. So I am using this lens to apply a modification function to my state. I'm doing an insert of this key, the validated let name. Oh, but that's just an accessor. I need to apply it to the... Oh no, it is in scope here. This should just be that. Like it is here. Okay. What do you mean lift A3 is not in scope? Doesn't lift A3 exist? It does, it's in control applicative. Don't I have my prelude in scope? I do. And my prelude doesn't have... Oh. Huh, interesting. My prelude doesn't re-export lift A2, lift A3. I don't know why it doesn't do that. Lift A2, lift A3. What do you mean it's redundant? What do you mean it's redundant? Oh, is it because... Is it because lift A2 is actually part of the prelude? It is. That's why. So let's do that. There we go. Now we touch the prelude, so everything has to recompile. So now we wait. It's interesting how much the analysis phase has been like the most difficult part of this entire like project. The first pass of it took me months. This refactor of like unbreaking everything is taking me months. I was dreading the lowering into AR, and the lowering into AR took me a week. I think it's because trying to find a good way to represent the different stages of the AST using trees that grow and other approaches like this, that's the tricky part, and that results in a lot of code. There's so much code to write here and so much to change, where the lowering into AR is difficult, but so much more concise. Okay, this is an if expression, which is this thing that has a location. And again, I have forgotten that this thing must take a with location, which means, yeah, then that's perfect. I give it the condition expression right there. And the validate function expression will set the location in my context properly, which is nice. So this is just basically validate the expression, like check that this is a valid expression in the context, and then check that, that its value is a Boolean, because that's what it must be for a condition for an if or a while. This is validate function expression. Wrong name for the function. So validate range expression doesn't exist yet because range expressions are not supported yet, because vectors and other arrays are not supported yet. So I assume this is just a matter of what I've said for the placeholder for this function is not correct yet. Let's have a look at validate range expression. And indeed, it returns just a typed range expression, while this thing expects that and a concrete type. So concrete type, which would be the concrete type of the elements, I suppose. I suppose for a, since this is a completely placeholder function, I don't mind changing its type to make it happy. I could just put like some A here for now anyway. Could not deduce control monad catch monad mask. Indeed. So here, that's a remnant of the fact that when I was doing the refactor, I just put monad m here as a constraint because I wasn't sure what my constraint would be. And I think I can just replace all of those by just monad diagnosis. However, I will still need that monad catch constraint somewhere. And where else to put it? I think it makes a lot of sense. Since the whole logic of the monad diagnosis is I want to be able to do finally, like, it is a core part of it, I think making it a requirement of the definition of monad diagnosis is not absurd. So instead of to be a monad diagnosis, something must be a monad, it must just be a monad catch, which I believe requires monad in the first place. Yeah, it requires monad mask. Oh, it's just... Wait. Bracket requires monad mask, which is which is the strictest one of the two. So indeed, I want monad mask instead, not catch. But I make that a requirement of diagnosis. Aha. Cannot deduce monad mask of diagnosis. Yes, because it is a new type. But I can, since it's just a new type around something that definitely has it, I can derive monad mask from it, and I will therefore need monad catch. And what was the monad throw? Okay, I'm just gonna... Okay. What else do we need? I just need to put those in scope. Monad mask, monad catch, monad throw. Ah. Oh, that, however, is extremely annoying. So this is my instance of if a monad is an instance of monad diagnosis, then anything stacked on it is trivially, well, not trivially, but is an instance of monad diagnosis as well, because it can always delegate to the underlying monad. Okay. Would it be enough in this context to say, let's try, would the compiler be happy with me saying, hey, by the way, monad mask of T of M? Would the compiler be happy with that? That requires an undecidable instance, which should be fine. Undecidable instances are just about when the compiler does instance resolution, it tries to enforce that when doing substitutions in the conditions, it always converges. It cannot do an infinite loop. So it has a check of like, well, this thing here, we can't guarantee for certain that it will not be an infinite loop, therefore it fails. Undecidable instances is just me saying to the compiler, it's fine, it will converge, you can disable that check, it will not be an infinite loop. If I get it wrong, the compiler will loop forever. But thankfully, I did not. I'm sure. Okay, we are at the point where I have warnings as error, which is great. It means that everything else is working. No internal compiler errors in this file. We love to see that. And now we move on to scope. Okay. What is wrong with scope? So parse local declarations is a function that looks at all of the declarations. Hello. Yeah, I had to take a break after last week. The 11-hour stream was really a mistake. Like it ruined my sleep schedule, and also like I've said it at the beginning of the stream, and I really want to emphasize this. I want this project to be somewhat educational. And like I don't have a big platform, but it's my duty to try to lead by example as much as I can. And I really don't want to give the impression that 11 hours, 11-hour binges are the right way to work. It's not, and that I will not do that again. And I was just exhausted after it anyway. So but now back at it, and on Monday I'm starting doing the Advent of Code, so I'll be alternating Advent of Code and this project all week next week. And the Advent of Code is only 12 days this year, so I might do all of it on stream depending on the difficulty. Because I really try to keep the Advent of Code streams accessible, like a lot more accessible than this amount of like here I have like higher candidate types, I do a bunch of very fun things. I try to keep the Advent of Code stuff a lot more accessible for Haskell beginners. um, so we'll see what the difficulty of days 10, 11, 12 is. If it's monstrous, then maybe I won't do them on stream. Well, we'll see. Okay, so here, what do I have? This function looks at the declarations in a module, usually at 8 p.m. Dublin time, plus or minus 15 minutes, usually plus more than minus, but around 8 p.m. Dublin time, all weekdays is my usual stream time. I'll try to update on Blue Sky and Mastodon if I can't make it, because like Advent of Code is a thing I really look forward to every year. The only thing is, a thing I do is I don't like, if you're not familiar with the Advent of Code, when you finish part one of a problem, you unlock part two of it. Since I don't do the exercise ahead of the stream, I discover what the problem of part two is live on stream, which can be challenging, but it means usually that I can try to prepare ahead of time. Okay, given the shape of part one, what do we expect it to be? Is there something interesting I can showcase for this? And I did that, and then I discover what part two is, and I have to improvise. But yeah, usually 8 p.m. Dublin time is when I start with the Advent of Code. And if I have time, if I want to do it, I might try to go back and do some of it in Brainfuck because Brainfuck is fun, like I do every year. Okay, so here, what we are doing, we are looking at all of the top level bindings, all the things that are defined at the top level of a module. We check a bunch of things. We check that that there isn't multiple declarations. We check that none of them are reserved identifiers. I'm not trying to declare something like int, for instance, which is a reserved identifier. We look at what's exported. We create the hash map of the definitions to then be used in subsequent steps. And we create the scope, which is a hash map from the path into that points to something to its role in the context. And we do all of that as one function. What is wrong here? So here, oh, it's not wrong in the function. I expected it to be wrong. So here, this for with key iterates on a hash map, like it's a traverse of the hash map with the arguments reversed, but we also take the key. Oh, but traverse with key doesn't take a tuple, it takes two arguments. That's the problem. I'm fairly certain if I go back to look at extra, yeah, it takes two arguments, the key, the value, not a tuple. That was the issue. Okay. It's not called name, it's called base name. That's an easy fix to fix. Lookup local definition doesn't exist. Okay. Oh, we are at the top level of the validation. That's good. I think lookup local definition is simply defined in the context module. Lookup local definition. Yep, that's where it is. I just need to import context here. Base name, not in scope indeed. This is called name and has been renamed to base name for accuracy. Let's fix that. Report doesn't exist. That is a remnant of how the code used to be before the refactor. I think in our validation monad, this is called fatal. Because the underlying thing would be is called report error, but this fatal wrapper around it extracts all of the information from the context, like location information and so on, to create the error from just this error message. In this case, the cyclic definition one. Okay. What do we have next? We have name, that's base name. Longer name, that's base name. When just, not in scope, okay? Let me just check something here. Why does validate definition return a maybe value? Because validate definition is the one that is part of the boot file. There we go. And it's part of the boot file because when I am processing something, let's say I'm processing a constant or something like this, and I find something else, I need to be able to say, hey, I need the definition of that one, which is basically calling validate definition back. And that would be in context. Validate definition. Oh, that is here for attempt to validate. That indeed gives me a maybe definition. So far everything is consistent. Attempt to validate, which indeed, okay. Yeah, I suppose that works. This calls an answer here. That's a bit inelegant, but that's fine, I think. So this function returns, like, does a try and returns that thing if it succeeded. And I suppose only puts it in the cache if it succeeded. Yeah, that's something that will need to be documented, but that's fine. But when just is not in scope, it is, I am 90% certain, in control monad extra. I always confuse the one of control monad extra and control monad loops, but in this case that's not a loop, so it's probably in extra. Let's just check when just is in control mode extra. Perfect. And I was importing it from control monad loops. Does control monad loops? No, it does not. Okay. Oh, no, that's a while just. I'm wrong. I misread. And indeed, while just would be in control monad loops. Okay. Couldn't match expected type. So there's something here where fatal here expects a message, and somehow this thing isn't one. So the cyclic definition, let's have a look. Oh, it just expects a name. That's incorrect. That's completely incorrect. It expects a list of base name. There we go. So what this list is, since we keep a stack, basically what happens here is we're analyzing some kind of definition A, like a constant, for instance. And it depends on something that we need to actually properly validate before we can use it, like a constant B, for instance. And B depends on the constant C, so we have to also validate that one. So we stack contexts on top of one another because we stack things because we have to just like continue doing the things to then go back down. But then C depends on A. We have a cycle, we detect that, and this function will give me the list from the first time it appears. So it's going to give me the A, B, C list. So like this will contain the full chain of dependencies that led back to the first thing. Like A depends on B, depends on C, depends on A. Okay. Except the function error cyclic definition is applied to two values. Oh, and it's the base name afterwards. Do I need to keep the base name? I probably don't. Just to check, I'm doing a break. Break equals A. On a list that, on a string that's A, B, C. And it's going to be the second, so it's going to contain the A. I suppose having the base name means I don't have to guarantee that this list is non-empty. Because I will want to know the name of the type, and if this is an empty, if it's a list, it could be empty. I have to handle that case. Including the base name here means if something goes wrong, the error message will just be weird, but I don't have to handle this. Because that stack could be empty, possibly. Yeah, no, I think I'm just gonna keep the base name. It's gonna be easier, so that means I'm probably gonna change the order of the argument. Because I think that makes more sense to me. Okay, we change diagnosis so everything has to recompile. That's fine. Validate parameterized type. That just means I need to bring types back in here. Validate type doesn't exist. Yes, that's correct. That's not something that exists anymore. We are validating a definition of a constant. A constant must have a type. It must be a concrete type. It cannot be a partial type or a parameterized type. That is, therefore, validate concrete type. Expect type is no longer something that it still exists. Expect type is still a thing. It just means that expect needs to be imported in this module. Okay. Resolved expression is no longer a thing. Validated is the one that I want. Aha, here I have some get compose stuff. I have introduced new aliases for this, I think, so I can probably rewrite this in a better way. Oh, except I'm doing a bunch of try nested. No, here I'm gonna need to get compose. Okay. But you're not in scope for some reason, which means let's import data functor compose. Is generic is no longer something that I have in scope. Do I still have a is generic function? Or is that a remnant of the pre-refactor code? It is all in old, so it doesn't exist anymore. This will be a function that... Do I want to make it is concrete, actually? No, I think generic is better. Because concrete could also be for a type, and I want to be very explicit about what I'm talking about. Okay, so let's go back to validated, the module in which we define the version of the AST post-validation, where we have the function info. Oh, actually, why is that a function info? Oh, it's a resolved function info. It's a resolved function because, yes, at this point, I only care about the type of the function. The actual function info, the actual symbol, will be processed at a later stage. So here, this is generic. I only care about it on a resolved function info. Great, let's go to resolved. The function info of resolved is the common one. Let's go to common. Function info, where are you? That's the one. Hello. And so here, I just need a small function is generic that given one such common function info, regardless of what phase we are in, gives me a Boolean. And a function definition is generic if not null. Wait. Oh yes, of course, it points to a fun type, which is this. Not null of the function parameters of the fun type. Which I can probably rewrite point 3 as being not null of the fun params of the fun type. There we go. Which is basically, we look at the type of the function. Does it have type parameters? If yes, it's not a concrete function. It is therefore a generic function. There we go. Because of course we don't instantiate. I use a model extremely close to the C++ model for this thing, where within a compilation unit, if a function is defined and it's not generic, it is included as part of the symbols of that particular compilation unit, and other modules that depend on it will link against it afterwards. However, if it is a generic function, it is not instantiated. I don't do validation on generic functions, only name resolving. And when a function is instantiated, so if I have a module A that defines a function foo with a type parameter, and a module B instantiates that calls foo of int, then it will be instantiated in the module that uses it and included as part of the compilation unit. So again, kind of like the C++ approach. Of course, I will deduplicate them across at the linking phase if it's linked in more than one module. That's the logic. Hence the need for isGeneric. This is, I'm calling validated. That doesn't exist. Validate is what I want. I think we're getting very close to this part of the code compiling. It would be nice to actually be able to test some stuff finally after such a long refactor. It's not too late yet. Not there yet. Okay, so what's wrong here? That's an error that's hard to read. That's a bit better. Couldn't match type node concrete functor, so a concrete type with maybe either... Oh, that's indeed something that's very weird happening here. What am I doing here? I am doing this get compose on the attempted args and attempted return, which means I have in my monad a maybe value that is just if all of the things I have traversed gave me something that worked. So here, when I ensure, I get a value in my monad that is the actual value if the thing succeeded, or short circuits with like just starts short circuiting if something went wrong. When I do both of the ensures, I get two values in my monad, and I'm lifting this particular operation inside the monad. That makes sense. However, the type seems to be very wrong. Or is it again that validate function arg? Oh, I think this is a traverse too that's wrong. I really need to make those things functors and just stop having, yeah. I'm almost tempted to do that now, so I don't carry around doing the, yeah, this is already a much more readable error. Ah, wait, no, actually, traverse 2 was correct. Damn it. Okay. But let's just do that thing now, so I don't make the thing compile with the wrong version. What I have that is extremely annoying is I have here in common, I have a function arg type. Where are you? There we go. I think I want to change this. I think I want to change this, and instead this is some kind of functor over value a's, whatever those are. It's just a functor. And show, of course. Like everything. Which means here, common function archetype no longer exists. This is a function archetype of a common path info, I think it was. There we go. And now that means I can go to validated. That being said, that's gonna break everything. Do I want to do that before it compiles? Nah, okay, I'm not gonna do that now. It's going to be a lot easier when I do this when it already compiles. So, I messed up the layout. Ah, well. And just bring this back here. There we go. And there we go. Okay, so no, I'll do that later. I would really like to do it. It's gonna simplify a lot of things, but it will also be a lot easier to do when I do it when everything else compiles. I'm gonna zoom out a tiny bit. Let me know if it's too small, just because it makes this kind of stuff a lot easier to read. Okay, so, and indeed this has to be a traverse 2 then, because they have names. Validate function arg is gonna be this thing. What are you unhappy about actually? So the first argument is expected to be a list of tuple identifier and a function archetype where the type is concrete. Yeah. And the actual is a list of tuple identifier and function archetype. Okay, so the first is correct. But the second, oh, this is a maybe of an either base name identifier. That's very weird. But I'm giving it a concrete type. For some reason, this thing, this function type info, expects it to not. Aha. I think what's happening is. Oh no, I did call validate parameterized type. Let me check the definition of validate parameterized type. Maybe its type is wrong. Although the file compiles, so I would be surprised. Where are you? Nope, this does give me indeed a parameterized type. So it gives me a parameterized type, like here as well, because since there might be some types, this function might be generic and might have type parameters, the types that appear in the arguments or in the return type of the function could be the type parameter or parameterized by the type parameter. So I need to take that into account. And the function type info that I'm returning, I'm doing this thing again where here I'm delegating and I'm not. Yeah, that's fine. I think I would prefer doing wrapping the constructor. I'm gonna do it. I think it's better. I think it's better to do this. And have the functions return and have the functions returns the inner type within. Oh, I have something wrong in this file. The indentation is no longer working. We'll fix that. Oh, yeah, I have some. There we go. Oh, that's not the only thing. Something else is wrong. And something is wrong and it's no longer doing highlighting properly. That's fine. And I will just do a quick thing like this. There we go. I think I prefer having the functions like if I am like doing a switch on the constructor and using another version of the constructor to wrap the value, I think it's better to have like I see that it's a resolve type alias and I output a validated type alias definition. And this function takes the inner thing and returns the new inner thing rather than actually calling the constructor. It doesn't make a big difference. I think it's cleaner. So let's make that change. Which means here, this is a validated type alias info in the output. This is whatever goes into here, which I think is a const expression. How is it called again? Validated const expression. A struct will be a validated struct info, and a function type will be a validated function type info. Again, if it's too small, let me know. I will zoom it back in. It's just for big functions like this, it's a bit easier if I see more scope. Okay, and so the error here, something is wrong with the type of the function type info of the output. So I'm outputting a function type info. Oh, I need to specify which one it is. I am in the case where I'm creating a definition, which means this is with the parameterized functor. I have parameterized types in my arguments. Okay. So indeed, I will have function archetype with f, so type parameterized types in my arguments, and a parameterized type in my return. So this is indeed a function type info with the parameterized functor. And here the function type info has 3 arguments. The list of identifiers, which is the types, the template types, the arguments, and the return type. So I'm doing a lift A2 of applying the function type info constructor to that and doing ensure. That looks good to me. So what is wrong here? Oh, is it just what is a function type as far as the previous phase is concerned? That's this thing. No, return is a maybe thing. So I do need to do a traverse. Oh, but that's the thing. Here I have this thing here from the output of the previous phase is a maybe type because a function doesn't have to specify a type in its output. So I'm doing a validation only if a type is present. However, in the output of this phase, there is always a type. And what that means is here, I will need, how do I do that? I think I'm just going to do it the old-fashioned way. Validated args is going to be ensure of the attempted args. I can zoom this back in. I know what's happening now. The validated return is going to be an ensure of the attempted return, and this validated function type info that we have constructed will be a function type info, the validated one, which has, I'm going to name the fields, that's their name. And in this case, the fun parameters are not changed because it's just a list of parameters. It's given unchanged. However, the arguments are the validated arguments that we have just processed. However, for the return type, we have maybe a type because maybe no type was provided. It's fine to not provide a type to a function, but after this phase, we want to always know what the type is because it will be useful moving forward. And that is basically a from maybe unit type of the validated return. This goes away. There we go. Validated struct info. Why do you expect one more argument? Because you expect the functor, okay? And I assume that in the case of a definition, this is the parameterized functor, because of course a struct can also have type arguments. There we go. Variable non-scope I. That, oh, I know what happened. That is why I had some weird indentation issues earlier. Oh, maybe something is very broken here. Let me check. Oh no, this is indeed, I stack the thing and then I pop the stack. Okay, so I'm gonna want, when this compiles, I want to replace this with a finally or a bracket again. Oh, did I? Yep, here this is a mistake. This is a typed context expression. Huh, why do I still have an error then? Here then. Somehow there is something down the line that expects this to be concrete, which is wrong. Oh, is this because this unit type is perceived as concrete? It shouldn't be. Or is it because... Ah, I know what's happening. Here I am saying, if this function is not generic, so that this definition as part of this module is not generic, I want to instantiate it. It needs to be part of the symbol map of this compilation unit. Therefore, I craft a function instantiation request that will be put in the context and that will process afterwards when I'm done processing all of the definitions in my function. A function instantiation request is this. It requires the base name under which this function was defined, a copy of the actual definition of it, so we can actually, instantiate it. And it requires its concrete type, because we only instantiate concrete functions where all of the types are known. But here, we have a validated function type info, this thing that we have created, where all the types are actually parameterized. So I think I am not going to keep this is generic info. I can leave the function, it doesn't matter. I think what I want to do is instead, and when I want to try, have concretize, I think is a function I have. I have it as a partial type. Okay. I'm going to want to try to make it... I'm going to try to make it a concrete type, And if that fails, that means it's not a concrete function, and therefore I don't have the value. If I do succeed, then I have the concrete function type info, and I can create the function instantiation request. So I think I'm gonna rename this partial to concrete. And I'm gonna duplicate it, and I'm gonna say parameterized to concrete. And it's going to be basically similar, except if I find a parameter... Wait, that's not... That's not true. That's not true. I was going to say, if this function succeeds, it means there's no type parameter in the function, therefore it's not generic, therefore it can be instantiated. That's not entirely true, because it would be valid to have a function that has a type parameter that is not used as part of its type. That would be weird, but that would be valid. Because I suppose that function could do a cast using the type parameter or something like this, but like just do something that doesn't require returning a value, and therefore it doesn't appear as part of the... Okay, so that means I get rid of this entirely. I will, in fact, rename the function before, like it was. And what I'm going to do instead, I have this reify type function that is able to convert some parameterized type into either a partial one or a concrete one. This function will throw an error. It will throw an internal compiler error if I find a type parameter and I can't find it in the mapping that is given. However, if I am in the context where I know the function is not generic, then it is indeed a logic error if I have a parameterized type that can't be converted. Therefore, I can use this function here. So this is going to be... I need to translate the return type, which is, so concrete return is a reify type with an empty mapping, because I know for a fact that there is no type parameter of the validated return type. Does that give me something? It's not in the monad because the only kind of error is an internal compiler error. So that's perfect. That's a lot easier. That's just that. And then the arguments are going to be just an fmap2, I suppose. So flip f map 2 of the validated arguments, where I'm going to do this case again because, again, I will change this, but I haven't changed it yet. If I get a by reference, or if I get a by value, I will do a by reference, or and I will do a by value. The validated doesn't need to be qualified in this module, I think. And this isn't a path, this is the inner type. Okay. And here, what do? We do a refi type with an empty mapping of the inner type. Okay. And with that, we can create a concrete function type info with the concrete args and the concrete return. And we can create our function instantiation requests with the concrete function type info. Okay, is that good? Ambiguous. Ah, god damn it. So this is the validated version. I really need to make those things functors and stop having to deconstruct and reconstruct them manually all the time. This is tiresome. When I can just traverse them, things will be a lot easier. Okay. Still an error here. Why does it expect to be some arbitrary type node? Because the actual is indeed a parameterized type. And this returns a function type info with the parameterized functor. So it should be obvious from context. Unless this thing is what's giving it trouble, do I need to do at parameterized functor here? That seems peculiar. Nope. So there's something about the way this thing is used. Oh, of course. Yes, of course. Of course. So this gives me a parameterized type, which is again the same type hierarchy of like either a leaf, an int, a character, or a struct that contains other types recursively and so on, with a functor that decorates the thing that decides what kind of types we have within. If it's a concrete type, we just have types. If it's a partial type, we have maybe. And if we have parameterized type, we have an either at every point in the tree, because at some point, instead of having an actual type, we might have t, the type parameter in the context. But here, I'm doing from maybe, because again, there might not be a type given as the function is declared. But as a result, the from maybe here needs to the value that needs to be provided if no type was provided must be itself a parameterized type. So it cannot just be a unit type, it needs to be right of a unit type. And now I think this would be better. Now we have moved on to something else. Okay. Ah, of course. So I'm just going to do it here. Once and for all. What do you mean? Base name is applied to too few things. Oh, because of course current name is just the lens, so I need to use the current name. Okay, we are past the errors where I thought we were. This is. Why do you expect a with location? Interesting. Yeah, that makes sense. Actually, we need the location. We need the location, which means here I cannot just give the info for a function. I need to give the full thing. Ah, that's annoying. No, I need to give its location, I suppose. Well, I already do that because I'm doing a with context. So, okay, I'm gonna cheat it a tiny bit. It's a bit ugly, but that's fine. I'll get the function location by doing a use current location from the get-go before we do anything else. And here, as a result, I can do a with location of the def location of the info. Okay. Next, what do we have? The type variable f2 is ambiguous. Okay. So here I'm briefing to something, but it could be partial type from context. It's impossible to know from context, so I need to be specific. Nope, I want this to be concrete. Okay. And I suppose the same thing is true here. Reify type is not explicit enough. This needs to be specified. I am doing this for a concrete type. And we are at the point where the errors that are left are the warnings, which we love to see. Because it just means that everything else compiles. Are we... Oh, almost. Oh, this is still a warning. This is probably just a shadowing. So I'm going to abbreviate this as def for definition to avoid shadowing definition. There we go. Ambiguous occurrence. This is... this is probably just the past definition at this point, because... Like, this is taking as argument the past definition, and I'm returning a hash map of the past definition. This is just about creating the top-level scope. I am not actually doing anything else. So those must be past definitions. Which means this is probably also just a past definition. No. Okay, that's import data list non-empty qualified as NE. Ambiguous occurrence definition. This one is again a past definition. Declaration doesn't exist, it's definition. A declaration associates a definition to a name. Expand scope with function argument. Those will be the past ones. No, I don't think that's correct. The role will not be a past one, it will be a resolved one. That's what roles are. Ooh, that's old. I still have a path info here. That's a past path info. And I don't need to specify the AST phase as an argument when I have a past something. Oh, should that be... It said resolved here. So maybe if I look at the monad for this phase, the name resolution phase, actually if I look at resolved, the types of the AST at that phase, what kind of let variable do I have? No, I do need to look at the monad. Because that's the thing I'm putting in the scope. And the scope will be a scope which contains non-empty role, and role is resolved. Okay. So that's back into scope. That is a resolved path info. There we go. Module exports not in scope. That would be instead module interfaces, which is this argument here, which is the stuff we have compiled in our dependencies so far. Couldn't match type role with non-empty role. Let's see. So I'm saying that I expect this to be a list of hash map from module name to scope, which is itself a hash map. And I expect actual hash map module name scope. Okay. And what do I get? Hash map non-empty identifier. That's the same thing. To hash map non-empty identifier role. What is the scope again? It is a hash map from path to non-empty role. Okay. Oh, but this is a hash map from non-empty identifier to role. So I'm not putting this in a non-empty the way it should be. That's what's happening. So something here does not put the roles. I see. Here, every time I do pure role. The reason why I have a non-empty list is because I want to handle collisions. So what I'm doing here is creating the scope. So I'm saying, well, to the name A, what is associated to that name in this scope? And it could be more than one thing. It could be something in this module where I have a constant A, or it could be something imported from another module. It's fine. However, if I make a reference to A in this file, then that will be ambiguous and the error message can be, hey, you have two different things. Hence, having a non-empty list of roles mapped to a name, to a path in the scope, because we need to be able to say there's more than one thing pointing to that name, but that's not an error in itself. Which means all of those roles need to be put into a singleton non-empty list, and I can do that with pure. validated bindings. What do you mean? Oh, because not indented properly. Actually, I'm tempted to... There we go. Oh no, validated bindings has to be in the monad. Okay. So I was wrong. So this has to be at the scope. Okay. So I'm just going to put this here instead, which means we are back to having a let here. Report doesn't exist. In this particular monad, it is also called fail. Wait. Nope. Shit. I am not in the validation monad, in the monad yet. I am in some arbitrary monad diagnosis, but it's the one of the color. I have not started the name resolution phase yet because I am in the process of creating the scope, which means I don't have access to fatal yet. Which means I only have access to the actual implementation of monad diagnosis, which is report error, which does not just take the message, it takes more than that. And it takes maybe a base name for the declaration and the current location. Oh, I do have the locations. Okay. But I do have the locations, but the error that I have is not specific to... Okay, but no, I need here... Okay, that's wrong. Here, I need to preserve the with location. So it needs to be preserved. Because here at the end, the definitions must contain the with location still. And those are created from the validated bindings. There we go. So those needs to contain the with location as well. Which means that here the definition from definitions... Okay, so it does contain the location information, so that's good. So it's just the types were incorrect. But the code was more or less correct. I suppose since the list of locations is non-empty, I can always get the first location. Which means here, when I have to report an error, this will be a diagnostic. And it will have no base name. I'm at the top level of the file. This is not an error that's specific to a particular definition. And I will be at this first location. So here, likewise, report error will need this. Because I am indeed creating a non-empty list of a role and a with location definition that is coming from the definitions. Yep, okay. So what is wrong here? Oh, of course. From list with an argument here is not correct. So this must be from list with, because this is indexed by... Yes, I am, in case of a conflict, I am doing a union of the values. Okay. I have now a for with key, but just like traverse with key, it doesn't take a tuple, it takes two elements. There we go. Oh, this takes a module name as an argument? Do I need that, really? Oh, I do. Okay. So, declaration top level bindings does need the module name as an argument. Perfect. Okay, name. What am I trying to do here? I am trying to get the name of the current declaration. Why am I trying to do that? Because I used it for type parameters, something that is probably not required anymore, but is a remnant of the pre-refactoring code that I will honor for now until we clean it. So I need to get from the current scope what the name of the current declaration is. That will be the declaration name. Find duplicates not in scope. Do I have a function find duplicates? I do indeed, in name validation. Which now we have to compile, okay. And that's the same problem of I am just... Oh no, I am in the resolve T now, perfect. So being in the resolve T, I have access to the diagnosis. So here I can just do an actual fail here. Perfect. When just M non in scope, that is a control monad extra. What am I using it for? Okay. Lens not used. Loops not used. RWS strict not used. Trans maybe not used. Sets not used. Okay. Interface just not used. Name not used. Yeah, I suppose here I don't have to do anything. Okay, we're back. Oh. Oh no. Oh no, it's fine. It's fine. I need to fix just a small thing. A lot of those will actually be monad diagnosis. This one for sure is. Next, what do we have? Here. Oh, of course. If I look at my monad, I have a reader of the resolve info on top of a state of the resolve context. The declaration name I want is in the resolve info, which is the reader. I'm using use, which is the one for the state, not for the reader. View is what I want. Okay, next, what do we have? So try validate the binding. Okay. Oh, this ensure sequence, that's okay, that's the old style of doing this. Let's redo this properly. This is an ensure nested of huh. Yeah, I suppose that I'm doing try through error basically. That kind of makes sense. For each of those duplicates, I want to throw an error, but I also want to not throw it yet until I've thrown an error for all of the duplicates, which is kind of funny. Try nested of that. Yeah, that makes sense. That's all good. Here, that's also an ensure nested. Of a try nested of. Let's see if it's happy with this. It is not. Validate binding. Okay. So validate binding. Where are you, validate binding? Is it the name validation thing? It is indeed. Okay. So validate binding gives me a unit thing. Okay. Now what I'm trying to do is, yes, of course, here I am getting the value out of it, which is absurd. I should just do that. There we go. That's not how that works. That's not how any of this works. So here I'm trying to make a role, but a role is not that. That's the different constructor. The role here is function argument. Oops. I probably don't need to actually specify this. And I am making a binding for each thing. And the identifier would be the arg name, I suppose. Okay. Hmm. What's happening here? I'm trying to create a rule, which is this thing in this context is a function argument with this function archetype. Oh, but it needs to be resolved. It needs to be resolved for this, which means if I so I need to first resolve them, otherwise that's a bit annoying. Unless I immediately at this point take the resolved version and let the color give me the right thing. That's probably the easiest. And this is the same thing again. This is a bunch of, yes, of course. So I can rewrite this as being ensure nested. Traverse. Try nested. Find duplicates, that hasn't changed. And that's also an ensure nested now with the new code of this for loop thing. And here I don't need to do a try. The try nested is at the top level here. And then therefore this is just pure of that. The function let variable is applied to two value arguments, but its type only takes one. Why does it only take one? I suppose it's because variables will need to have their own binding anyway. Wait, so if I do that, yeah, for the purpose of name of resolution, the name is enough. So I don't need the var type for this. Okay. For the scope, I don't need the type. Okay, that's fine. That's again non-empty path, non-empty role. And now we are at the warnings again. It's always good. Ah, yes. first location. The binding for definitions, shadows, okay. Because I have the definitions here as an input, which is just a list, and I want the map. So instead, it's going to be a definition map. That's a better name. This shadows something from lens. I'm just going to hide the thing in shadows. When a diagnosis not found in scope, that's because it's coming from internal diagnosis. I'm also expecting location to not be found, so I'm just going to immediately add it to the list here. Come on, there we go. Ambiguous occurrence struct info. That's not that surprising. So here the argument is a parsed version, and the output is a resolved version. Okay. And I have a bunch of places where I do that. Okay, so let's try to see. Let's do it that way. I want to find all of the instances of some kind of word that contains a bunch of letters followed by past. Oh, wait. There we go. And I will want to replace this by past dot. There we go. That looks good. And I can go back and just check here. Those can be removed. Well, first, let's maybe do the same thing, but for resolved. Resolved. Ah, that's... Nope, that one is correct. No, this one is correct. This one needs to be changed. This one needs to be changed. This one needs to be changed. Okay. I can just remove the unnecessary parentheses now. Let's clean this. It's gonna be nice next week to do some Advent of Code and have a so much smaller scope of a project. For a change. I'm having fun with this, but it's gonna be nice to have some slightly more self-contained problems for a bit. Okay, that should be everything for this file. Ambiguous occurrence, that's fine. That's the one from RWS. I'm not using RWS. It's fine, I can just remove. Past type alias info is... Okay, so that means I need to go to resolved. I'm gonna sort this list. I'm gonna copy it, go to past. Yep, there's more here, perfect. And I'm just gonna replace this with past. Ooh, 47 out of 50. We're not that far. So function type is something that I need to add to those things. Function type, and I need to do something for past. Function type. The idea behind this is that every stage exports its own set of types, but a bunch of them happen to be defined using the common stuff. But as a result, just re-export an alias that points to the common thing. Come on. Nope, still nope. So maybe this function type isn't correct. Because I'm taking a past function type and I'm returning a resolved function type. The resolved function doesn't exist. I have a typo here. That's why. Come on. I want to believe. Expected type it when the m is a constraint. Interesting. Because I have the wrong kind of arrow here. And I oh, had I not been through that file? Interesting. Oh, maybe I have actually. And a lot of those do not do any kind of try. Oh, a lot of them do actually. So I'm just gonna do the same thing again of replacing all of those monad m with the corresponding monad diagnosis. There we go. Which means I will need to bring... Oh, diagnosis is already in scope. Perfect. That's good. Create imported scope. All of this comes from the scope file. We are at top level of the resolution phase. Couldn't match type identifier with base name. I'm trying to create a hash map from base name to role. Is that correct? Is that correct? I don't think this is correct. Because if I look at interface, yep, exported is identifier to role. So this is identifier to role. Common definition resolved. Oh, this needs a location. This needs a location. So that's a hash map base name with location resolved definition. Which, okay. So something here loses that. I suppose then that resolve definition takes the full definition that contains. Oh no, okay. I decompose it here. So instead, I'm going to do this. Put the try nested here. Get the location as being the location of the definition. Resolved will be a run resolve T of declaration base name, top level scope, and definition location. Indeed. I'm just going to put it on one line, that's fine. And the result will be a pure, and that's not the definition, that's the located of the definition, and the result will be a pure with location, or actually it's going to be the resolved put inside the definition. Okay. This is an ensure nested of a try nested here. Okay, so now this file I hadn't done, okay. Oh, so this is purely putting the constructors back, I think. Except for the enum def, that doesn't require them because that's just, okay, that's how it rolls. Okay. Will this need? No, the constructors are the same. It's not going to need to be qualified. That's convenient. But this needs to be pure. Okay. Get compose not in scope, but I will probably want to rewrite this to not be using this since I have aliases that do this for me. This is an ensure nested of a traverse 2 of try nested. There we go. Just the same thing with the compose, except I have aliases that do that for me. Const info, what's wrong here? Expression type versus yes. Okay, so this is saying I'm losing the location information somehow. I'm losing the location information. Why is that? So I have a const info. If I look at common, const info, identifier, common path info, expression type. Okay. So I try to resolve the expression. Okay. This will fail if it did not. Okay. So I suppose resolve expression is probably wrong. And indeed, it loses the with location that it must not lose. So this is going to be result here. And I'm going to do the same thing of putting at the end of this pure the result inside of whatever it's called, the expression. Okay. Ah, is that not explicit which one it is? Oh, no, this is that this. I've said const info, this is a function info. Oh, something is very wrong here. Something is very wrong. Struct params when the constructor was called const info in resolve function. I think when I wrote this, I must have been very tired. So the thing is, the function parameters are coming from the fun type. There we go. More get compose that I'm gonna rewrite. This is oh no, actually, this is indeed get compose. That one is fine. But I do need to have just need to have import data functor compose in my scope. This is a function arg type. Okay. Where are we now? So I try this one, I do a get compose of the compose of try of the thing. Okay. So that's a lift A3 of the if info, that makes sense. Oh, but this is resolve else. Well, I want resolved else. There we go. And this is resolved body. Okay. So resolve block is going to be yet one again. Oh, I should do that now. In validation at the top level here, I have a bracket again. So I should use bracket again. Yeah, I can just use bracket here. And bracket I'm going to use with, so control mode at catch in scope. I just need bracket. Which is going to be init validation, clean validation, perform validation. And I am going to introduce aliases for all three. Not sure why it's not indenting properly. Something must be wrong in this file. Init validation will be simply... Oh, they will need to have access to a few things. I don't need the def stack, I think? No, I don't. So I will need the base name. And that's probably about it. But perform the validation will need the base name and the definition, of course. What's this def stack thing? Yeah, it's what it is. Okay. Where does definition is here? Okay, which I'm gonna rename def because otherwise I'm gonna have a conflict. So I will need a definition to perform the result. Okay, so initially the init of the validation will be purely modifying the stack so that we can do all of the detection. I guess I can rename this setup and tear down, which is slightly more conventional name. Setup is just registering the fact that we're pushing this to the stack. And then tear down is going to be it's gonna be doing this, I suppose. Oh, actually, do I need? Can I? No, I can't. Okay, that's fine. That's fine. So the setup is I put that in the stack. The teardown is I remove it from the stack and I mark the thing as validated regardless of whether we succeeded or not. And performing the validation, given the base name and the definition def, will be I don't need to do a try. I can just directly do a with context base name the whole thing. And I can probably just like with location and deconstruct this thing, which means I can just use location here and located here. Okay, that gives me the result. And I don't have to do a when just because since I don't do a try, this will always fall through if something went wrong, which means I always have the result. I can put the result in there always. Wait, it's probably result rather than def in there. Okay. Yes, it's unhappy about something in terms of... Oh, no, it should be fine. What are you unhappy about? I must have some parenthesis somewhere that's wrong. Yep, indeed, that's exactly the problem. That's what's wrong. Okay. Bracket. Let me check control monad catch. Bracket underscore. Yeah, it looks good. What's the problem there? Oh, yes. I didn't name the arguments. Base name. Base name. Okay. perform validation. This... Aha, so I no longer do the try there. Do I want validate definition to give me a maybe? I think as established, yes, I need validate definition to give me a maybe. Although I don't like it that much that way. That's fine. Just means I can just do a try of this. Okay. Control monad extra. Not needed. Oh, I don't need to give the base name as an argument to these things. It's already in scope. It's already this thing. That's perfect. So here, the only thing I need to do is to give the definition. I don't even need to give the definition. That's perfect. So here I'm just naming them for the sake of it's cleaner if it's named, I suppose. But then as a result, here I can't deconstruct def because it's just given as an argument. Unless... Where am I using it? Nowhere. There we go. Okay. Resolve block takes an extra argument, which is going to be pass in this case. Oh wait, no. It is this thing. It is the expand scope with variable. And what does expand scope with variable take as an argument? It takes just the identifier. Yes, of course, we just changed that. Which means I can just do that. There we go. Oh yes, I did this because I wanted to replace yet another thing with validation monad. I want to replace that with another. Where's where with the context? Yeah, there we go. To do use finally. This is also just a bracket, and this time I'm just not gonna name them. This is the thing that I do at first. Then when it's done, I drop it, and the action is action. There we go. I just need control monad catch in scope. In resolution, I think I wanted to do the same thing for resolve block. Yeah, there we go. This is going to be a bracket, and I'm going to name them in this case setup block, tear down block, process block, just that it's readable. Setup block is just... Oh no, in this case I need... It's not a bracket like this, it is an actual proper, so I just get the scope as it was. The teardown will be given the parent scope, we restore the parent scope to what it was. And the process of the block will be set the scope for the block. Wait. I do a try here. Oh, because here I do an ensure sequence kind of thing. Okay. I don't need to do that. I can do instead, this is an ensure nested of, for each statement here, try nested of set the location and traverse try nest. Well, I need to try nested actually. This is just traverse resolve statement. Okay. That's cleaner. Bracket is coming from control monad catch. I will want bracket and bracket underscore, I think. I think I need both in this file. Oh, process block requires the parent scope that I ignore. Resolve the body, typo. Expand scope with variable doesn't require the type. Whew. Oh, something is extremely wrong. I suppose it's just resolve path with the path argument? Looks like it was, okay. Okay, so what's wrong here? I traverse, resolve expression to fields. This is probably a traverse 2 because... No, it's a traverse 1 because we've location there. But the struct expression constructor takes the resolve path, indeed, then takes a non-empty list of... Oh, so traverse resolve expression on the fields is wrong. This is a traverse 2 because I'm going through the name of the... Okay, that's done. This is not a resolve expression, this is resolve a path. Path name no longer exists. It is now... God, I haven't been through this again. It's now called path base. I never know if it's base or body. Unused. We love to see that. Perfect. One more file that's done. Or at least that's down to warnings. Exp shadows an existing because it is a top level thing. So here I'm going to name them just E, I suppose. It's that close to the used site, it's not that bad of a name. Okay, where are we now? 48 compiled, 49. This requires the AST passed, I suppose, which is the input of this. The input of... Oh, God, are we at the end yet? Finally. it compiles, the lib compiles. The main doesn't compile, but the project itself compiles. Ah, okay. There's so much that's broken. There's so much to do still, but we can run some basic manual tests for today, at least. So we have, because the simplification phase is broken. Where are you, simplification? The simplification phase is currently, like, half of it is labeled as unimplemented, but it works on. Oh wait, no, did I fix it? Wait, did I actually fix it? Oh yeah, it's working on the validated phase. Nice. Oh well, except haha, it's unimplemented an expression. Okay, no, it's almost there, but not quite. Okay, so the main thing we're gonna need, we have now this analysis thing that, given some hash map module name interface, a definition cache, a function cache, a symbol cache, a module name, and a module, will give me the interface of that results from doing all of the analysis of this module. I could define some kind of like compiler monad that keeps track of this, but I don't want to do this at this point, because if it's just like, here are the arguments, here are the results, then I'm free to organize my main however I want. Maybe I'll change that later on. But for now, I think this is fine, which means it is time to go to, how's it called? Is it called bin? No. What's the name? Oh, yes, of course. There we go. Let's go to the main of our compiler, which is extremely basic for now because, like, again, we don't have a finished compiler yet. And I'll put the interface here as well, as a reminder of what's in the interface. Perfect. So we have a very basic usage here that's not really, yeah, I'm not gonna touch any of this, I think. Those print functions are a bit ugly. This is really like some debug stuff. Let's try to make it a tiny bit better. I guess this is not too bad. We go through the arguments and we exec state with some kind of cache. Which is the exports, the definitions, the symbols and functions. So this is going to be renamed the interfaces instead. That's the module name, that hasn't changed. Source, lift.io, read file. Parse the thing. Crash on error. That's good, that's fine. And analyze module will need to take as an argument the interfaces. It will need to take the definition cache, which is definitions, the function cache, and then the symbols. Then the module name, and then the past AST, which is the module. Oh, all of this will need to be... This will need to be in some kind of diagnostic monad. So I guess I can just do a run diagnosis T of all of this. Run diagnosis T of all of this. Which means the result I have at the end here is diagnostics result. I don't have the diagnostics at this point. Here, what I have is the interface. I don't do the simplification phase because it doesn't work yet. I update my state insert module name interface in the interfaces. And for the rest, definitions, symbols, functions, I expand that by doing a union with the new definitions, symbols, functions. That seems good to me. I'm removing the IR and everything for now because we don't have that. Now, I'll just do a traverse print of the diagnostics. And then at the end, case result of, if it's nothing, error, panic. Otherwise, if I do have the result, which will be my interfaces and my definitions and my symbols and my functions, what do I do with that? What do I do with that? I will probably just want to print stuff for debugging purposes at this point, because we don't have the lowering to AR, we don't have the simplification, we have nothing. I think the definition is the most important part. The function is just a copy of the raw definition of functions for generic functions. Yeah, I think for now, the definition cache is what I want. Although I suppose I could just... Oops. Let's print everything. Definitions. Functions and symbols. And that's gonna be a traverse. But I would probably want to traverse with key, I suppose. So this is gonna be more a... Yeah, all of those are hash maps from base name. Yeah, okay, so I will just want to have hash map strict extra in scope. And I'm just gonna do I have those render path, render name? Oh, the render name is gonna be very broken, I think. I need a render base name as well. Rendering name is going to be... name params is the name of this thing. If there is no name params, then it is purely a matter of render. I'm in the wrong function. It's this one. Name params. If it's empty, then just render base name of the name base. Otherwise, render that. And put the types in between brackets. Rendering a base name will be a module name, which is just a path. So render base name will be this, intercalate with this name module. And then at the end, this plus raw identifier of the name ident. There we go. So now I have ways to render all of that. I could just use... It's fine. Okay. So now I can do for each for with key of the definitions, and I get a base name and a definition. I can do a print of render base name of the base name and print of the located definition. I don't need the location information. And I can do the same thing for functions and symbols. I'm gonna remove this code because it's IR stuff that's no longer compiling. So same thing for functions, where it's a base name, and for symbols, it's name render name. Okay, and for those, there's no located, I think. There we go. Let's try to compile this. Let's see if this main compiles. Nope, it doesn't. Okay, let's go back to extra. Let's introduce for with key underscore. That does not return that just ignores its result. Okay. I just need a 2 minutes break. I'll be right back. Sorry for the wait. I should really invest some time and maybe pay an artist to have some actual, like, nice backgrounds and everything at some point. Okay, because this was not technical difficulties, this was just a quick break. Okay, we're back. So, traverse with key underscore doesn't exist? I'm surprised. No, I guess it doesn't. Might as well introduce it. Because if I look at traverse underscore, it is still the same thing. Yeah, okay, so I will probably want to introduce traverse with key, which is the exact same thing but with the argument swapped. I'm just gonna spell it explicitly. That's gonna be a bit better. Like, just to make it more readable. There we go. And traverse with key will be the underscore will be the exact same thing as this version, but with those two arguments. Flip the function first, the hash map second, and traverse with key underscore of some function f and some hash. It's just I can write it 0.3. It is void of traverse with key. There we go. Okay. Run diagnosis T is not in scope. I will need internal diagnosis. Located means I need representation location. There's no such thing as base name. This is a name in this scope. So there's somewhere here where I'm expecting some location where I don't have location. I'm using the name definition everywhere. That's not necessarily the case. Oh, definitions here. This is symbols. That's not the only problem. Okay. So here. Okay, so what am I doing wrong here? There's a difference probably between the interface definitions, the interface symbols, and if I look at interface, definitions is the definition cache, no function cache, symbol cache, no, those are the same. So as long as I'm indeed giving definition function symbols, okay. Definitions, symbols, functions. The union should be fine. Definitions with definitions. Second argument here. Here. Symbols coming after function here, but third here, third here. Huh. What is wrong then? Wait, no, I want to keep this for later. What is wrong? Validated definition. Okay. So I have something where, oh yeah, I'm doing located on the definition, but definition is not. I think I don't have any location on any of those. The only one I have is function. Function have definition. So function is the only one where I need to do the located thing. For definitions, I don't. There we go. Okay. Does that compile? Not yet. I suppose, yes, here I will probably want to just decompose the interface to get access to the individual fields. Insert. Oh no, I do need the interface. Yeah. There we go. We're so close to be able to run tests. Render base name. This gives me text. I have just some put string there. I'm not gonna bother. I'm just gonna unpack. That's ugly. This is definitely throwaway code. I'm okay with that for this evening. The import of IR is redundant. Yeah, I agree. And I'm not using interfaces at the end. Yeah, that's probably correct. And now, main compiles. So, let's open a new... In the spirit of doing things the ugly way for now, let's create test 4. Oh, test 4 already exists. What's in it? Almost nothing. Perfect. Let's use test 4. Okay. Oh, but PS is a horrible name. I still haven't decided what the extension should be for this project. I used PI in the past, let's keep that. Okay, so I have an empty file, and I will want to run stack build and stack run on test4 / main. Oh, it's running the wrong one. Doesn't exist? Oh, it's probably running in the wrong... Okay. Okay, so that works. So when I run it from here... Oh, I'm in the wrong folder. That's why. There we go. Okay, so now let's try a few things. Let's try a constant x of type int of value 4. What do I get? I get a definition, which is main x, because we are in the module main, which is a constant definition of a typed thing, which is an int type, and it's an int literal constant expression 4. Okay, that looks good to me. What if it is x as int multiplied by 2? I get that it is indeed a int literal const expression 240. I'm gonna check quickly just to be sure, but if I import data character and I do ord of x, it is indeed, yeah, okay, that's correct. Perfect, so the constant declaration seems to work. What if the type is wrong? What if I do const y is an int, but its value is the character 4? I get an error. At test4 main at line 2 column 1, parser error. Huh. because that's not const. That is something that doesn't make sense. And here I get instead a diagnostic. The declaration is main y. The location is uh, address 48, line 2, colon 16. The message is error wrong type, expecting int got character. Perfect. We can remove this y that's broken. Let's create a struct foo that has a type argument t, and it happens to contain a field bar of that type t. Internal compiler error. Okay. Parameter name not found. So we tried to do some reification into something concrete, and it failed. Parameter name not found. Okay. So we have something wrong with type parameters. Okay. Oops. Wait, is it work? It's okay. Sound is working. Okay, so we have an issue with type parameters. So for now, maybe let's not try that. Let's do a struct foo that has an int that passes. Foo is a struct definition that contains a field bar of type int type. Okay. I wonder where the reification happened, actually. I was expecting to have a stack trace for that. I'm surprised we didn't. I suppose I should go and modify every function that calls report internal compiler error so that it has its own stack trace. That's what I need to do next. Let's do a function a1 that takes a value z of type foo and returns an int. This will return z point bar. What do we get? That compiles. Oh, it's 1 a.m. I should probably stop. But here I do get a definition of a1 in my definitions. It's a function, the type of which is no type parameters, takes an argument which is z by value, and it is a struct type which points to main foo with no type parameters, and it returns an int type. And the symbol here, the instantiated version, doesn't have the right or anything like this because it's now concrete, and has the entire code of the thing, including the expression, which is a return statement that does contain something, which is of type int, which is a field access expression of a struct info, yada yada yada, and accessing the row identifier z, and then on the right hand side, the identifier is bar. Yeah, okay, so that looks good. I'm a bit annoyed by struct. Do I have the same problem for generic functions? If I have a function t that takes a value x of type t, and I return a thing of type t, and I just return x, do I get an internal compiler error there? I do indeed. Okay. I really need to stop. One last thing. Okay, I still have a bunch of them. Let me make this a tiny bit bigger. That's a bit bigger. There we go. Let me have a quick look at the ice module. Has call stack is what I want. I want to add this constraint to all of the functions that do. So here, there we go. That's all for this file. Perfect. Here, this function does it. That's all for this one. This one does it. It requires another constraint, which is this one. What I'm basically doing is just every single function in which I am calling the thing to report an internal compiler error, I am putting an annotation basically that tells the compiler, hey, this function actually has access to a call stack, which means that next time I do I do report a internal compiler error, I will have some amount of stack trace there. That's the assert module. That's why there's so many of those. A big reason why I've done this refactoring that has taken over a month, two almost at this point, has been I wanted to remove a bunch of the report internal compiler error in the next phase, the lowering into IR, because a lot of it was the checks we make in the validation phase are not persisted in the type system. Therefore, we have to redo them. Moving forward, and a lot of information is lost, and a lot of internal compiler errors are not required. There's a few places like this where in between the resolving phase and the validation phase, there's a few places where like, oh, I know from context this must be a function, this must be a struct, but sometimes the thing can still be incoherent. Maybe it will be worth thinking about a smaller scale refactor to try to see if there are things we can do to reduce the number of internal compiler error by improving the output of each phase. Oh, maybe that wasn't enough. Let's see. To improve the output of each phase, to reduce the amount of internal compiler errors required. This one I've already done, yeah. This one is different. I'm gonna need I can try to compile. Oh, it's not gonna compile at all because I need to import GHC stack in a bunch of files. Wait, no, I don't need to do that. I'm just gonna here. I'm gonna export that as part. By the way, I'm re-exporting GHC stack in every module that imports this module. There we go. Hello. You arrive as I'm about to stop. I'm done with the gigantic refactoring that has taken a month and a half, 2 months of work. I'm at the point where I'm testing things. It's broken for the evening. That's to be expected. It would have been weird if things had worked on the first try after, that long of a change. I'm just trying to see if there's some obvious things I can fix, and then I'll stop for the evening, and I'll be back on Monday. Okay, this should compile. Perfect. And we're back to running. So now what's the call stack? Retrieve type parameter. Oh, nice. So retrieve type parameter as part of the validation of types. This doesn't have... I wonder if I should make all of my functions have a has call stack by default. I should look into that. Retrieve type parameter. Okay. This happens, validate, retrieve type parameter. It's only called once here for validate type parameter type. Right there. And that means I am trying to validate some kind of type, for instance, a parameterized type. Yeah. And I find a type parameter. Okay. And that means I need to be able to retrieve it in the scope. Okay. That means that in the struct definition, when I was validating the struct definition, let's go to validation. Yes, that's what's missing. I have in my validation monad, in my context, I have the type parameters that point to the concrete type. And here they must have been missing. Which means that when I start my when I start the validation of... Oh, nice, you use Haskell for work. Where do you work, if you don't mind sharing? I used to use Haskell for work, and I no longer do, and I miss it. Let's do a struct. Indeed, when I validate a struct, I do validate parameterized type on the fields, but at no point did I set the context to contain the type parameters. So that's the problem. So it means, but I don't know what the concrete types are. I can't know what the concrete types are at this point. Because at this point, I don't necessarily have... Okay, that means I have to rethink how I validate parameterized type in the context of a function definition or in the context of a struct definition when I'm not in the context of a concrete type and I don't have types to match. That probably means I need to rewrite the validation of parameterized type to accept the fact that, no, actually, it's fine to have... Wait, I'm an idiot. validate parameterized type, that function is just wrong. Yeah, it's just wrong. The whole point of this function is to say, well, I have found a type parameter. That's just gonna be left, pure left of the base name and the parent name. I'm an idiot. This must have been copied from another type, another function. Okay, so if I go back to my test file, okay, now this compiles. So this function b1 is not part of the symbols of the module because it is a generic function and is therefore not instantiated. Oh, it should be part of the functions. It's not. That's a mistake. Okay, so we need to fix this. But it is part of B1 as a type, as a validated type. And we know that this function name has a type parameter t. It has one argument x that is given by value, the type of which is the t of b1. For now, all of my type parameters contain the reference type that they come from. Like this comes from tb1. This is probably not required. I will probably change that at some point, but it was required pre-refactor. And it returns something that is not, like, it's not like, it is yet again left because it is just a type t parameter. Perfect. What happens if I make foo a foo of t where bar is of type t as well? Does it compile? It does not. What's my error here? Foo here is probably a problem. Yeah, okay. I have a diagnostic here where the message... Oh, I have a warning name shadow. Interesting. Why do I have a warning name shadow? Oh, because this X here shadows this X here. Yeah, I guess that makes sense. And I have another diagnostic. Incorrect type parameter count, where foo expects 1 got 0. So this one is wrong. So it's going to be a foo of int, I suppose, here. And now that compiles. Perfect. It's still missing the function. I need to fix that, but we can fix that later. What else do I want to try? A1 is still in the symbols because it is not a generic function. Let's try. If I have a constant a that is an int and that is equal to b plus 1, and I have a constant b that is an int that is equal to c plus 1, and I have a constant c that is an int that is equal to 0, that should be fine. Yep. A is a value 2, b is value 1, c is value 0. However, if I make c equals a plus 1, I should get error cyclic definition. Ooh, I get a lot of error cyclic definition. Ah, haha, that's a problem with the way I label that the things have been validated, I think. Oh, wait, that's why I named shadow. Cyclic definition here. Yeah. I think I have one, yeah, A, B, and C, all three end up having. So that's a bug I should be doing. Okay, I'm gonna leave a to-do for next week. So here in the bracket somewhere of the validation, I need to ensure I do have the bracket, I do have to tear it down. So it should be put invalidated. Huh. Weird. Okay, so I need to invest. I need to investigate. I'm gonna put it in there actually. Otherwise, things seem to be working more or less okay. So next week we finish rewriting the simplification phase. In like light of everything being refactored, we fix some of the errors we found this evening. We plug the lowering into IR back, and yeah, we're getting there. I really need to go for the evening. It's getting very late for me. Thank you everyone for tuning in. I'll be back probably on Monday with some Advent of Code first, and maybe some Advent of Code in Brainfuck if I feel like it, and then resuming all of this. Thank you again for tuning in, and I'll see you next week.